For session of the conference. If you're ready, I want to take Mr. Bayar the table. Thank you for his presentation until now. Please.
Hello everyone, this is Kelly Abdülcelil from Turkish Aerospace. Today, I will present tolerance and mechanical properties comparison as built whole and real whole of polymer additive manufacturing. Additive manufacturing actually means manufacturing by adding. The basic and common principles of additive manufacturing is layer by layer production. The idea brings a total different approach to design, manufacturing, and implementation of engineering parts and components. One of the key features is hole. So holes is very important for the assembly and testing. So we study for the actually the making and drilling the hole. The main categorization of additive manufacturing, we can divide it 7 categories. And this actually comes from the standard, ASTM standards, divided 7. So 7 different categorizations. The one of them is photopolymerization. We can say SLA. We are using photopolymers. There is one laser or a light, and it make cure the photopolymers. And the second one is metal jetting. Droplets are selectively deposited, and we are using the wax and photopolymers materials. The third one, and our study focus on the material extrusion. It's very common. You also use at your home. Material is selectively dispensed through a nozzle or orifice in a layer. We can use the plastic, nylon, FDM, FSF, and sand material. The binder jetting is also the other categorization. Liquid bonding agents select deposits to join powder materials. We can right now use metal, plastic, ceramic, sand, and the most important feature is we can print full color. And also we can make a method. I would like to notice that with binder jetting. The powder bed fusion actually the most right now for metals most famous and improved method. So this is a thermal energy laser or electron beam selected to fuse the region of the powder bed. We are using laser or electron beams, and we can melt the metal powders. And it's not common, but also this additive manufacturing, the sheet lamination. Sheets of the materials are bonded to form an object, and we can use for metal, paper, wood, and plastic. And the last one is directed energy deposition. Focused thermal energy uses the material that is deposited. We are using wire or powder metals, and for sources to laser or electron beam also we can use. Our main this study focus on the FDM, means fused deposition modeling. Fused deposition modeling is an additive manufacturing technique based on extrusion of thermoplastic through the heated nozzle. The extrusion is moved in the XY plane to deposit to the material in the desired trajectory in each layer. Upon the deposition, the polymer quickly solidifies due to the lower temperature of the surface. Once a layer is completed, the stage is moved down by layer thickness and the deposition of the next layer. We can use these. One layer is completed, the platform is done, and other layer will start. What is the advantages and disadvantages? Advantages is device and raw material expenses are relatively low. Industrial scale devices can get expensive, and our actual study is using industrial scale machines. Custom systems are easy to implement, and there exists a huge open source community. Almost all thermoplastics are compatible with the technique. We can use ABS, PLA, PP, PEI, and PA. Dual nodal printers enables multi-material printing and water-soluble support. Disadvantages: mechanical properties strongly depend on the printing orientation. So this is main challenges actually, and also it make the very difficult to mechanical analysis because of the depending on the printing orientation. The overhangs beyond 20 degree needs support structure. Warping, shrinkage, nodal plugging, and poor adhesion to printing bed are common problems. Poor surface finish, especially at the side wall, also the other disadvantage. We use two different materials and two different machines. Those machines are industrial scale machines. We are using for aerospace parts. One of them is Stratasys F900, and we are using Ultam 9085 material. It's based on PEI. And the other one is Markforged X7, and the material is actually onyx based on polyamide. We are produce a dog bone tensile specimen according to ASTM D638 type 1 specimen, and all of the parts with the same CAD model produced. And one of actually the product hole free dog bone tensile and the drill holes and as-built hole specimen versus subject to study involving micro-examination, measurement, and tensile testing. And our orientation is XY. So we just focus on the XY. Because also we have a different direction, but we just focus on the XY direction. Also, specimens with holes have been examined with the Zeiss Smart Zoom 5 digital microscope, and also you can use the outside the microscope. All specimens with hole diameters have been measured with this microscope, and also with tensile mechanical testing were performed according to ASTM 638 type 1 samples, and our thickness is 3.3 millimeter, tested with accuracy speed of the 1.2 inch minutes. And also our all specimens were tested at a room temperature. You can see our equipment. Results and discussion. I would like to notice. You can see the if as-built means actually the printer make a hole. So if we make a hole with printer, you can see the porosity is nearby the hole. So it's make actually worse in mechanical properties. And also when we measure the because of the ovality, we examine for ovality. We make a measurement 0 degree and 90 degree. So we can we examine drill holes achieve 20 better precision compared to the holes produced by additive manufacturing. So if you need a precision, it's better to drill the holes, not make a with printer. And you can see our stress strain curves from our ASTM 638. And so this is all of them one material. This is for Ultan material. This is onyx material, polyamide base. You can see the free from hole, and this 4, 5, 6 is the drilled holes, and the 7, 8, 6, 9 is the printed hole. So when we put all the results one graphics, we can see the UTS. We can see the UTS, and we can see the without holes according to around 50 megapascal, and drilled holes around 40 megapascal, and as-built hole is around 35 and 38 megapascal. And we examine the onyx material. It is actually 47 megapascal without hole, and drilled hole also around 30, 37 and between 35. And the worst case is as-built hole. It's less than 35 megapascal. So the opening of the 3 millimeter hole in the tensile test specimen results in a 75% reduction for both materials. And also we examined actually the both materials, the same results, actually the same percentage reduction. And drilling the holes provided 12% higher tensile strength compared to the creating the holes through additive manufacturing. Additive manufacturing holes had some material deformation around the hole edges. I already mentioned that. The defects impacted mechanical properties worsening. So, as a result of the study, various differences were observed between additive manufacturing produced holes and conventional drilled holes for for customers. The detailed results are provided below. Can we hole quality? The conventional drilling holes show improved surface finish and uniformity compared to the manufacturing produced holes. The conventional drilling process allows for better control over hole dimensions and reduced surface integrities. And material integrity, according to material integrity, holes created through the drilling process exhibited better metal integrity and strength. On the other hand, additive manufacturing produced holes had some material deformation around the hole edges. According to accuracy and tolerances, drilling allows for achieving higher accuracy and tighter tolerances in hole dimensions, leading to better fit and alignment of fasteners. Additive manufacturing produced holes had slightly looser tolerances and showed minor deviations from the target dimensions. And according to time and efficiency, the additive manufacturing process demonstrated higher efficiency for producing holes, because when the manufacturer we can make a hole, especially in non-complex geometries, as it eliminated the need for secondary machining operation. Conventional drilling requires additional setup and machining time, of course. According to cost consideration, the initial setup and equipment costs for drilling might be higher, but the manufacturing cost in the overall cost per hole can be competitive due to the lower labor cost for the complex geometries. According to the post-processing requirements, conventional drill holes often require deburring and surface finishing, adding extra post-processing steps. In contrast, additive manufacturing generated holes usually require minimum post-processing. Overall, the study showed that drilling can offer significant advantages in producing holes for customers, especially in terms of hole quality, accuracy, and metal integrity. However, the choice between the two methods should consider factors such as geometrical complexity, production volume, and cost construction. Thank you very much for listening. Do you have a question? Okay, thank you very much.
Thank you for Mr. Bayar for the presentation. And after that, with the title of the effect of temperature on the tensile behavior of additively manufactured IN718 for as-built and direct edge foundations, I want to introduce Ms. Alay to your presentation. Introduce myself. I am Tuğçe. I have been working in metal welding technology and non-defective testing center for 10 years, and also I got my PhD degree from Metallurgical Engineering Department at Middle East Technical University. And my supervisor is Professor Dr. Cemil Halkangül. Today I will present our one part of my PhD study. The title is The Effect of Temperature on the Tensile Behavior of Additive Manufactured ICMATSE 718 for as-built and direct edge conditions. So, I know. So, sorry. This is my outline. I will present my presentation. I will present my study with this order. You know that at the beginning of my presentation, I want to say the importance of additive manufacturing in ICMATSE 718 superalloys. Maybe you know that superalloys is a very popular material for the high temperature applications, and ICMATSE 718 superalloys are generally used for the high temperature applications due to their outstanding mechanical properties at the high temperature level. And but these superalloys have low machinability, so due to their low machinability properties, casting or forging cannot be used for the sometimes for the complex shape geometrical components. So the solution is actually additive manufacturing. In the previous presentation, presenters mentioned lots of different additive manufacturing methods. And selective laser melting, the other name is laser powder bed fusion technique actually. Selective laser melting is very popular additive manufacturing technique for the fabrication of this kind of superalloys actually, and it's a very revolutionary technique for the complex shape material. In this study, we will focus on the SLM method. This method provides to produce a complex shape geometrical parts and also provide to control final circuit quality and final microstructure. And also this method provides to reduce the waste of the product and also reduce the cost. But of course, there are some disadvantages after this method. After SLM technique, materials sometimes includes some materials sometimes include internal strain, anisotropic properties, and undesirable phases in microstructure. In order to solve this kind of problem, post-processing heat treatments are generally used to the embryo specimen. And as I said in the previous slide, superalloys in nickel-based superalloys are generally used for high temperature applications. But what is that temperature range? For the nickel-based superalloys, this temperature range is about 500, between 500 and 700 degrees Celsius. Because of the including various type of elements, these nickel-based superalloys, ICMATSE 700 superalloys, shows excellent balance of corrosion and creep resistance, high strength and toughness, and excellent metallurgical stability at extreme loading conditions. So when compared to the SLM techniques to the conventional production methods like casting and forging, researchers found that SLM samples showed higher mechanical performance at high temperature levels also. So in this study, in the light of all this information from the literature, in this study, we will investigate the tensile behavior of SLM produced in ICMATSE 700 specimens under varying temperature conditions, and also we will focus on the different heat treatment conditions also, because as I said before, as I said in the previous slide, these superalloys are generally used for high temperature application, but when we look at the literature, lots of and many of the researchers have been focused on the room temperature mechanical performance, but these alloys are generally used for the high temperature applications. So there is insufficient literature research for the high temperature properties. So we will focus on the high temperature, mechanical performance, and also we want to observe the effects of different type of phases inside the microstructure under the high temperature deformation condition. So let's move on to the experimental procedure. For these purposes, we produce cylindrical shaped product. It's not shown actually. We produce cylindrical shaped product by applying selective laser melting technique with choosing strike pattern scan strategy. And then we apply direct aging heat treatment to the cylindrical exhaust surface. Direct aging means two-step aging heat treatment processes. It includes, first of all, the specimen was heated up to 720 degrees Celsius and holding at that temperature for 8 hours. After that, specimen cooled down to the 620 degrees Celsius, and at that temperature, specimens were cooled for 10 hours, and after that, air cooling was applied. This is called direct aging, actually. After direct aging operations, we analyze the as-built and heat-treated samples by optical microscope, scanning electron microscope, and electron backscatter diffraction methods before and after deformation, and also X-ray analysis was done. After that, tensile tests were performed at 550 degrees Celsius and 650 degrees Celsius. When we look at the microstructural result about the picture, SEM, scanning electron microscope images are shown. When we look at the SEM images of as-built sample, chain-like lavage phases were observed in the interdendritic region. But when we look at the direct age heat-treated samples SEM images, we were also observed the lavage phases. These lavage phases were not dissolved after heat treatment. But we also observed some strengthening phases, gamma prime and gamma double prime inside the matrix. These provide to increase yield strength and tensile strength to the material, actually. And then we investigate the electron backscatter diffraction color map analysis. These color maps are called EBF maps and can be also called inverse orientation Hall figure map. When we look at these Hall figure maps, slightly weak texture along the 001 plane were observed. But by using these EBS maps and by using some MATLAB code software program, we calculate the geometrical necessary dislocation values of the as-built and direct age specimens. These geometrically necessary dislocation values also used for the indication of the internal strain inside the material. So from here, it can be said that the high GMD values are observed in the as-built and the direct age specimens. So after that, we tested specimens under two different temperature conditions, 550 degrees Celsius and 650 degrees Celsius. The two strain curve are shown in here. And from here, we can observe that in the as-built specimen, the yield strength exhibited an unusual increase as the temperature increases from 550 degrees Celsius to the 650 degrees Celsius. And it can be explained by the, and also the, when we look at the elongation values also decrease as the temperature increases. It can be explained by the dissolution of the primary carbide and formation of the secondary carbide during hot deformation, actually. And also, when we look at the direct example tensile test results, no significant change in elongation over the same temperature range. However, yield strength decreases with increasing test temperature. And we can explain this situation by the decomposition of the lava provides the niobium to the matrix, and this niobium are used to the secondary gamma prime and gamma double prime formation during deformation, and these secondary gamma prime and gamma double prime precipitation formation cause the increased yield strength, actually, at 550 degrees Celsius. But when we look at the 650 degrees Celsius, the yield strength decrease, and it can be explained by the formation or in the formation of induced delta phases inside the matrix region. You can see in the right side of the picture, actually. These acicular shaped delta phases cause to act as a citric concentration site during deformation, and these additional citric concentration sites cause to decrease yield strength, actually. The other important result from the when we look at the mechanical test results and the strain curve, there are some serration regions in some samples deformed at 550 degrees Celsius. These serrations indicate the dynamic strain aging phenomena. This is some kind of yielding phenomena, actually, can be observed at some specific temperature range and specific strain rate. It's actually observed due to the interaction between solid atoms or precipitate and dislocation during deformation. And in the literature, there are three types of dynamic strain aging: type A, type B, and type C. Type A and B is related to the dislocation generation phenomena during deformation. But type C is related to the second fold formation mechanism during deformation. And when we look at the as-built sample, we observe type A, the dynamic strain aging regime, and it indicates the dislocation motion mechanism observed during deformation inside the microstructure. It indicates, actually, and it can be resulted because of the formation of secondary gamma prime and gamma double prime precipitates. These precipitates are in the range of nanoscale, actually. We were analyzing the TEM analysis, and these precipitates are also small, and during the deformation, it interacts with dislocation, and it causes dynamic strain aging mechanisms also. And also, when we look at the direct age samples, stranger, mixed type of dynamic strain aging regime was observed. This regime indicates that at the beginning of the deformation, dislocation generation, the other name may be used, or one bypassing mechanism are occurred, but then at the end of the deformation, this mechanism converts second fold formation mechanism, actually. It can be explained like this. So, in the light of all this information and results, we can say that there is a complex relationship between microstructure temperature and deformation mechanism in additively manufactured Inconel 718 samples. And also we can summarize all these results as like that. First of all, at 550 degrees Celsius, the phenomenon of dynamic strain aging was detected, resulted from interaction between dislocation and solid atoms or precipitate. And the other important result is that the higher GMD values observed in the Esbjerg specimen, it caused the earlier precipitation formation of the secondary phases during the formation. And also the other result is that direct age heat treated specimens deformed at 550 degrees Celsius at the highest strength due to the absence of the apicular shaped delta phase. And the last result is that at 650 degrees Celsius, unusual behavior in the York string and temperature-related disturbance was identified in the direct age samples due to the induced apicular shaped delta phase and also formation of secondary carbohydrate grain boundaries. Thank you for your kind attention. It's very important and very
Thank you very much. Our speaker is the Akşam. Akşam. Its speech will be on the future of welding engineering, inspection, and quality in manufacturing.
Ladies and gentlemen, first of all, I want to condemn the terrorist attack that has been realized yesterday in Ankara. We condemn that and we pray for our markets. I'm Özgür Akçam. I'm the founder of GSI Turkey. I'm a metallurgical engineer and a welding engineer, and I want to thank Mr. Professor Ateş for the opportunity that he has provided us to make the presentation here. My presentation is about welding technology, especially on welding engineering training, which is, of course, related somehow to additive manufacturing with one technique, but it is somehow different and focused on the heavy industry. Maybe you all know about that. So, a welding engineering program is a vocational training program, and which is in the framework of European community, let me say, the EU. This is European credit system for vocational education and training. In that training, we have 75 credits as welding engineers, which is quite at high level, you know. And this training, as I told you, is a professional training based on an engineering training first. So in the engineering training, the candidates get their basic information, knowledge about materials, for example, about structural design, for example, or some basic engineering fundamentals. And then with that fundamentals, they are allowed to visit the welding engineering training. So the management and the qualification and certification of that training is under the responsibility of IIW, which is International Institute of Welding. So under that International Institute of Welding, there's an European Welding Federation in which Turkey is also one of the members. So Turkey is a member of IIW. That's why we can issue in Turkey international welding engineering diplomas. Not only welding engineers, but at technician levels, international welding technicians and international welding specialists. These informations are quite important for the young people designing their future. And the level of welding engineering in the European qualification framework, EQF, is level 7. And the level 7 is one step below the highest level, which is level 8. It is equal to the master's degree in the university. So it is accepted so in the European countries. So the 75 credits means there's a interchange or there's a transfer between the countries in Europe. It means you have that much of credit so that you can visit the training in Turkey and you can work in France, or there can be vice versa exchanges. Of course, we are talking about an international program. It means what we call it here in transfers and exchange of professionals in the European countries. But the diplomas gathered after the training is valid almost throughout the world. For example, if you go to Japan, it is also known and accepted. Or in countries in Africa, it is accepted. Provided that the country, the land, is a member of IIW. Okay? So I have compared the level 7, the meaning of level 7 in according to EQF in Turkey and in Germany, because the most relations are between the two countries, and my partner is the German country. That's why I have compared that. And it is, of course, we have to mention that the old system has been established by the Germans since 90 years, and now it's a European and international system. That's why I wanted to compare that, because there's a conflict. Many people think when we are talking about an engineering program, we automatically think that it's an academical program. It should be in a university or something like that. But when we talk about welding engineering, which is managed and controlled by IIW, we are talking about a professional training. It's a vocational training. That's why we need to plan, or we need to, how to say that, we need to show where it lies in between all the other systems. So in Germany, it is equivalent to a master's degrees in higher education qualification. In Germany, it's Magisterarbeit, Diplomarbeit. Maybe you have heard about that. In Turkey, Turkey is also a member of EQF, and it's a graduate system, ECVT, is also valid in Turkey. We accept it as a master's degree. So it's a professional degree equivalent to a master's degree in Turkey. And the EQF level is 7, as I mentioned before. But the highest level in EQF is level 8, which is PhD. So with a welding engineering diploma, you cannot go and say, I have a master's degree in welding engineering, but you can say that it's an equivalent training. So the program consists of 448 hours of training in 4 main subjects. Welding methods and equipment. This is module 1. Module 2 is materials and their availability. Module 3 is design and construction. And module 4 is fabrication and quality. So the candidate must visit the lectures in all these 4 modules. And in total, he or she has to spend almost 450 hours. And according to the guideline of the IIW, which is IAB 252, and workload is 836 hours, which means you can imagine in a master's degrees program for 4 years, for 2 years, the workload is less than hours. It means you have to visit the lectures for 450 hours, and then you have to study about 400 hours as a class. So it's a hard work. It requires long times of lectures and long times of study. That's why we have double study insurance. So why is it so important? Why we have to study that much to get the diploma? So first I want to define special process. What is a special process? In ISO 9001 defines there's a sentence called special process. What is a special process? Let's look at that one. Special processes are those outputs that you cannot confirm or verify as functioning until their delivery. Which means you are producing a product, but you cannot make sure about its quality until you finish it and until you test it. For example, if you are, maybe additive manufacturing is also like that. During the process, you cannot change anything. You have to wait until the end, until the process is completed. And of course, you can control that by non-destructive testing methods, but you can never be sure about its mechanical properties without testing. So it means you have to produce the product. It means you have to produce the part so that it will have the necessary mechanical properties after you complete it. So to confirm this type of process, you must prove the process ability to achieve the desired result. You have to prove it. It means you can say that you have produced a machine, you can run it, and you can check it. But if you produce 100 machines, you cannot run and check all 100. So you have to be sure, you have to make sure that you have produced the quality, which we call quality assurance. After the product is finished, you are sure about its quality. So this is a special process. And in order to establish that quality assurance, the companies must have a continuous inspection. For example, the incomes, the material must be used. The process must be under the supervision of a professional, which means personal is very important. When we are talking about welding, for example, the welders need to be qualified. And the welders need to be coordinated by qualified, which are engineers, technicians, and specialists at the highest level. So welding is also a special process. That's why you can never be sure about its functions before you test it destructively. So you cannot destroy each product. So you have to produce the quality together with the production. So that's why we have many steps to achieve our final goal. I will talk about that later. And, as I mentioned before, quality assurance has the highest importance during the process. You have to assure the quality. You cannot control it. Quality control is expensive and time-consuming. It's good. You have to control the quality by any means. But it is better to be sure about the quality without controlling it. Because let's say I have produced that one and I am controlling it, it's not functioning. Either I have to repair it or I have to throw it away to the scrap. So I lose money and time. But if I'm sure that all the product has the same quality, so I'm confident. Yeah. And that's why to get the final target quality assurance, all processes need to be coordinated. And in the welding technology area, welding coordination is done by either welding engineers or welding technicians or welding specialists. And as I mentioned, welding engineering training is runs for 450 hours, technicians training for 350 hours, and specialists for this 280 hours. So these are long trainings and important. So what do we have after the training has been accomplished? So you are the masters of the technology in the required section as welding engineers. And you can solve high-level complex and unpredictable problems. We have many problems in that. You cannot be each time, every day, you have to solve problems. So you have to have an analytical way of thinking. Normal for engineers. The ability to manage high complex technical and professional activities or projects related to welding application. Imagine you are building a bridge. I have visited a site for the bridge that crosses the Marmara Sea from Yalova to Istanbul. It's a huge project. In Turkey, we have huge projects. We are lucky as welding engineers because there are many problems to be solved in our area. So I think as young professionals, you have to be very often on the site. You have to see what the engineers are doing. So taking responsibility for decision making, which is very important. Decision making. You have to make solid decisions. Sometimes our young candidates, so this week we are performing our oral examination now in the welding engineering course. We ask a question and the answer is, yeah, it may be done like that. It's not engineering. It's, I do it like that. It's engineering. Not maybe. You have to make sure. You have to be sure. And you have to be confident. That's why the training is quite important. You have to take responsibility. Okay, and you have to take responsibility also in managing the professions. You have to manage welding inspectors. You have to manage NDT, non-destructive inspection technicians or professionals. You have to manage welders. You have to manage welding operators. Okay, so it's a high responsibility engineering. So education and training, it's a very rough summary. Of course, we can talk hours long, but I will make it short. So the training has three parts. The first part is a general part. It's around 90 hours, 88 to 90 hours, which you gather the general knowledge about materials, welding equipment, processes, and design. Very general, just like you have gathered in your engineering training. And then the second part is hands-on training. You weld in 4 or 5 different welding methods. You make welding because you have to know what a welder has a problem, what kind of problems a welder has. You have to understand it. And the most important part is the part 3, which is called specific part. And then in this specific part, you learn welding specific aspects in engineering. You again learn about materials, but this time about their welding methods. And then you learn more about welding techniques, which you have never worked with. And in module 3, you make some simple designs related to welding, not related to structural design. Okay? And in the module 4, now, quality systems, quality assurance, how I assure. And please keep in mind that quality assurance in our welding technology is a very high level risk management. Welding is a very useful and flexible process, very economic, fast, and you can do many things, but it has very high risks. There are bridges that were collapsed because of a 3 millimeter welding imperfection. So you have to be sure about it. That's why it's a long training, with long training hours, expensive, and you have to interrupt your work or your study. So that's why we need also in welding engineering modern training techniques, which is called blended learning, which is e-learning, means self-learning, because as engineers, we know how to learn something. We don't need somebody to teach us always. We can read and interpret the things, standards or problems. We can read and understand, and we can solve. Supported by classroom training, the most important session of the training is done in classroom with direct interference with the candidates, and supported by online training. Now it's very more, everybody wants to get an online training. No, online training is not a solution. It can only be a support for that training. Because, as I mentioned, it's a very important training. We have very high responsibilities. Without online, we can live, but without classroom training, we cannot live. Okay. Our aim is to have coordinators that are qualified to manage the risks in special processes. So special processes, welding is one of them, as I have mentioned. The other one is adhesive bonding. And maybe one process in additive manufacturing, it's also a special process. You know, what other special processes we have? Painting, for example, coating and corrosion control. It's also a special process. So which means qualified personnel is required, qualified material is required, qualified controllers are required. We are living in Turkey where we have too many investments, and we have very much investments on industry. That's why we have people that are controlling. So non-destructive testing, for example, it's a very huge and very important aspect. And the people that are performing that tests, they need to be qualified. They need to be qualified with a responsibility, for example. You can go to industry and see many people with certificates at high level, but they are not qualified. They are buying the certificates. So that's why my advice to you, the young professionals, if you want to have a qualification, first learn the subject and do not pay attention only for the paper. Okay? You need to learn to be different. So where do we work? Steel structures, railway vehicles, special vessels and tanks, refineries, power plants, pipelines, automotive. Wherever you see metals, we work. Okay. So these are the examples. So I have to come to the end. For example, these are international standards, EN 1090, for steel and aluminum structures. There must be a welding engineer working on that. EN 15085-2, certification for railway vehicles producers. You need welding engineers, welding professionals, and also non-destructive testing professionals. You need. And ISO 3834, general welding structures, you need welding engineers. So the scope is quite wide, and the scope is the world itself, not Ankara, not Turkey, not anywhere. So I have mentioned that similar areas are European adhesive engineering, international metal additive manufacturing coordinators. These are similar aspects. That's why the coordination is also important in these two systems. Okay, This is the end of my presentation. Thank you very much for your attention. If you have questions, I'm happy to answer.
For the applied do you have any requirements for the apply international welding engineering program or getting the certificate? For example, maybe specific bachelor degree or GPA maybe.
Thank you. Getting the certificate as a requirement, you have to pass the exams. But to be accepted to the training, you have to have a valid engineering diploma, PhD. Or the students at the fourth year, they are also allowed to get the training, but they cannot have the examinations. They can have the examinations after they bring us their diploma.
Thank you so much.
No, yes, we have some physicists, unfortunately not in Turkey, but in Germany we accept them, but physics engineers are accepted because it must be an engineering program. Computer software engineers, they can also be allowed. We have, up to now, we have two or three computer engineers in our program, but it was the most difficult program for them because they are not aware of materials, etc. They are allowed. All engineers are allowed. Equivalent to master's.
After finishing your course, right, they will get the degree, master's degree.
They will get the international welding engineering diploma.
So just I want to come somewhere. Now that the degree is equal to master's degree, after finishing your course, why don't we start PhD writing or something like that? Can we think about that like that?
It has to be clarified with you. But in Germany, you can do that.
Yes, okay. Thank you very much. Any question? And I would like to change to Professor. No problem. You are like a professor for us. So I would like to invite Hakan Ateş for giving great.
Yüksektir. Bana yetiyor. Bu arada Özgür Hoca ve hocam kaynak mühendisliği eğitimini kendisinden aldık. Kaynak mühendisliği diploması kendisinden aldık. GTO'da. Ardından dedi Arkalı Lisesi'de uluslararası kaynak testleri oldu. Konferansı ilgili. Onu da oldu. Endüstride çalışmalar var. Özgürleri diploma. Hocam oralarda serileri çok kesinlikle konuşuyoruz. Öğrenciler var. Daha ağır yani. Burada hocanın sormuş olduğu sorulara şeyden de hocamın vermiş olduğu terminolojiyi çok dikkatli kullanarak vermişler. Diploma demesi çok önemli. Farklı yapıp yapma ama bunlar etkilere bağlı, yoksullardan alacak kararlara bağlı, ödeyeklerde olan yerler var. Ama akademisyen maaşıyla yaşarken Özgür Hoca ile tanıştıktan sonra yaptığımız işlerde birazcık üçüncü rengi daha kırmızıya doğru döndü böyle hani gıdayı bol almış, yeniden oldu böyle birazcık daha güzel ekonomik varlıkla hayatını icra eden gençler kaynak mühendisliğinde, kaynak inspektörlüğünde çok güzel gelecekler var ekonomik anlamda. Hocam olduğu için gurur duyuyorum. Kendisinden ders dinlediğim için gurur duyuyorum. Yaşça aramızda çok yaş farkı yok. Ama hocam, ona burada plaket vermek, onu burada dinleyebilmek bizim için bir onurdur. Arkadaşlarımızla da paylaşayım istedim.
Bir de arkadaşlar, bana da çok gelen sorulardan bir tanesi, mezunlarım da konuştuklarında ben de metalurgistim, böyle Üniversitesi'ne. Hocam işte kaynak mühendisliğine başvuralım. Bir de tahribatsız muayene uzmanı diye sorular geliyor. Ben de kendimle hiç düşünmeden başvurabilirsiniz diyorum. Evet biz lisansta ders anlatıyoruz ama sonuç itibariyle bir kaynak mühendisi diploması vermiyoruz. Sadece tabii malzeme mühendisi diploması veriyoruz. Onun için arkadaşlar vaktiniz ve durumunuz müsait olduğu sürece kesinlikle kaynak mühendisliği ve tahribatsız muayene uzmanlığı kurslarını takip edin ve başvurun, bu sertifikaları alın. Çünkü ileride çok işinize yarar. Now, the other speaker is Yalma. Burada mı?
Buradayım.
Online mi?
Buradayım.
Welcome, Yalma. You hear me then?
Yes, I can hear you.
Okay, here you are. You can start your speech, your presentation.
Okay.
You can introduce yourself shortly if you want.
So can you see the screen? So is it okay? Screen is okay or?
Sorry.
Ekranımı görüyor musunuz? Evet.
Yes, we
Can I
see.
start?
Yes, you can. Please.
So screen is okay?
Yeah.
Okay, okay. So good afternoon, everyone. I am Emine Yalman from İskenderun Technical University. My title presentation is an assessment of the potential of the conversion of pomegranate membrane into value-added products. So firstly, I will mention about biomass. So what is biomass? Biomass is defined as the unfossilized living waste and residues that emerge as the origin of all organic matter and living organisms that contain carbohydrate compounds living on the ground, underground, and waters in a certain period of time. So biomass energy resources are mainly divided as classical biomass and modern biomass. Classical biomass are wood, plant wastes, animal wastes. And modern biomass are energy forestry, forest industry wastes, wood industry wastes, energy agricultural products, agricultural wastes, and urban waste. So problem statement. So what is the problem for this research? The first problem is related to fossil fuel, because today rapid industrialization, increase in trade, population, and demands cause a rapid increase in consumption, and the need for energy is gradually increasing. And with the beginning of industrialization, fossil fuels have been used as the basic resource in the world. However, consumption of fossil resources cause environmental pollution, global warming, climate change, and disrupt structure of nature. And besides negative effects of fossil resource in the environment, reserve amount of the fossil resource are limited, and their formation takes a long time. Also, with the Paris Agreement, it is aimed to keep global warming to no more than 1.5 degrees and lower carbon emission to 0 by 2050. And the second problem is related to biomass, because with the decrease in population density in rural areas due to the development of technology and industrialization, the amount of biomass is gradually increasing, and approximately 130 billion tons of biomass waste is generated annually. And the low utilization of this large amount of biomass is still a serious problem. That's why there is an urgent need for a renewable, sustainable, and economical resource alternative to fossil fuel. So in the study, pomegranate membrane, which is an agricultural waste from lignocellulose biomass, was used to investigate its potential to be converted into energy and value-added products. But why pomegranate membrane? Because Turkey is the natural spreading area of pomegranate. Change in pomegranate production in Turkey on a yearly basis can be seen in the figure. Accordingly, while the total pomegranate production in Turkey was 59,000 tons in 2000, this amount increased every year and reached 537,000 tons as of 2018. And according to 2019 data, pomegranate production is carried out on a total area of 300,000 acres. So this large amount of waste needs to be evaluated. So as methodology, firstly, pomegranate fruits were collected from Adana province in Turkey. The collected pomegranates were broken and the membranes were separated from the grains. The pomegranate membrane were dried in an oven at 100 degrees for 3 hours. Then it was grounded in an agate mortar in order to make them ready for analysis. So while the functional group and phase change of the pomegranate membrane were determined by FTIR and XRD respectively, its morphology and elemental compositions were determined with SEM and EDX analysis. So results of XRD. From the XRD results, it is seen that pomegranate membrane has both amorphous and crystalline structure. And XRD results shows 002 101 diffraction of graphite and a structure close to typical XRD pattern of the disordered carbon. Results of FTIR. Results shows that pomegranate membrane contains cellulose, hemicellulose, and lignin. From the figure, it is seen that there is a peak at 2,927 1 per centimeter and OH strategic vibration. So which proves that cellulose, hemicellulose, and lignin content. Results of SEM. SEM image shows that pomegranate membrane consists of scattered and hollow structure. So it is expected that this structure is suitable for energy storage by facilitating electron transfer. And the results of EDX. From the results, it is seen that pomegranate membrane has a high oxygen content. So the high oxygen content means that it can be easily burned in the production of energy from the biomass. And another point worth mentioning is that carbon content in the pomegranate membrane is higher than oxygen content as a result of its cellulose and hemicellulose content. Finally, total inorganic atom content in pomegranate membrane is quite low, below 100%, and can be useful in obtaining bioenergy. So as a conclusion, we can say that pomegranate membrane is a valuable material, should be evaluated due to its cellulose, hemicellulose, lignin content, amorphous structure, porous surface properties, high carbon, and low inorganic content. Thank you.
Thank you very much for your good presentation. Any questions? Enteresan bir konu. Soru, o zaman ben bir Türkçe soru sorayım hocama yani.
Buyurun.
Hocam bunu ticari olarak nasıl değerlendireceğiz?
Ticari olarak. Hocam şimdi ticari olarak olması için öncelikle bir çalışmaların yapılması gerekiyor. Şu an bizim dediğimiz şey, şu an hani değerlendirilmesi gereken bir madde diyoruz. Bunların daha ön çalışmalarının yapılması gerekiyor.
Evet yani ama sonunda bunun bir ekonomik değere sahip olan bir ürün
Tabii
halinde.
istenilen sonuçlar elde edildikten sonra satış kısmına da getirebiliriz.
Anladım.
Ülkemizde bahsettiğim üzere hem büyük miktarlarda üretiliyor ve bu bir atıktan bahsediyoruz. Atığın enerjiye ve değerli ürünlere dönüştürebilirsek ne mutlu ülkemize, dünyaya.
Sağ olun, çok teşekkürler. Thank you very much for your good presentation and attendance. Herhalde Bu da tamam konuşmamız. Hocam görüşürüz. İskenderun'a selamlar.
Görüşürüz. Aleykümselam. Ankara'da
Özellikle
selamlar.
Rektör hocama bol selam söylüyoruz.
Aleykümselam. Sizlere de geçmiş olsun.
Bir mukavele sağ olun efendim. Teşekkürler. Sağ olun.
Görüşmek üzere.
See you.
See you.
Bundan sonraki konuşmacımız sanırım bir arkadaşımız kaldı. Sözel. O da mı olmadı? O zaman bağlanalım. Gidiyor mu? Versin bakalım.
Açık mı mikrofon?
Açık.
Dear participants, first of all, I would like to state that I am sorry that I cannot be with you today. I am sure that this year's advanced material science and engineering and high-tech device applications international conference will be held successfully. With these feelings, I hope that the information and technological developments that the conference will provide to the participants will be very useful. My field of study is nanopolice, which has caused performance improvements in thermal applications, especially in recent years. Today, I prepare a presentation for you on the performance improvements of magnetic nanopolice in thermal systems. Energy is one of the most essential inputs for the socioeconomic expansion of countries. Energy resources are very significant in terms of economic and social development. People's demand for energy resources and energy consumption increased with the Industrial Revolution, and this increased population growth has continued with industrialization and urbanization. Heat transfer improvement studies, which are gaining importance today, have a very significant support in the industrial field and in terms of energy saving. Conventional working fuels such as water, oil, ethyl alcohol, and air. In industrial, air conditioning, heating, cooling, electronics, etc. play an important role. However, the low heat transfer properties of these conventional working fuels used in heat transfer systems are one of the major obstacles in terms of efficiency and enhancement. Various methods have been employed in order to increase the thermal conductivity of the working fluids that are used in thermal systems. One of these methods
was by adding nano-sized solid particles into the base fluid, conventional working fluids. These types of fluids have also played an important role in increasing heat transfer efficiency and convection heat transfer coefficient compared to conventional fluids. The aim of this study is to improve the thermal performance and consequently to increase the thermal efficiency of three thermal systems: air-to-air heat pipe, heat exchanger system, concentric tube heat exchangers system, parallel and counter regimes, as well as thermostrong natural convection heat pipe system with magnetic nanofluids formed by adding different metal oxide particles in nanosize to the conventional working fluid by various methods. Due to these developed working fluids, the particles dispersed in the base fluid increased the surface area and the heat holding capacity of the working fluid. Thus, the heat transfer capacity of the system is also increased. The aim of this study is to study the effects of utilization different types of magnetic nanofluids, mono and hybrid magnetic nanofluids, on the performance of thermal systems, which was achieved by applying an experimental and numerical study to improve the working fluid by adding magnetic nanoparticles to the base fluid. As a result of the experiments that were carried out with these three systems, the extensive comparisons of the system under magnetic nanofluids have been done at different input heat, powers, cooling fluids, flow rates, and various inlet temperatures of the aperture zone were observed. Moreover, these magnetic nanofluids were prepared with two concentration ratings, 1 and 0.5. Experimental data were obtained based on the operating combinations that were applied for each system. What is the magnetic nanofluids? Suspended magnetic nanoparticles in various base fluids. Magnetic nanoparticles are typically 1 and 100 nanometers in diameter. They can manipulate it by using magnetic field. They are often made of ferric oxides, iron, or metal such as iron, nickel, or cobalt. The aim of the work using different types of magnetic nanofluids in different types of thermal systems such as heat pipes, heat exchangers, and heat recovery units, etc. Find the effect of the magnetic nanofluid on the efficiency and thermal enhancement rate of each thermal system. Determine the overall heat transfer coefficient and surface heat transfer coefficient of the hot and cold streams. Calculate the improving efficiency of the both systems and compare it with that with distilled water. Preparation of the magnetic fluids, generally the preparation of the magnetic nanofluid is done by two steps. One, nanoparticle synthesis. Second, preparation of nanofluid. The most common synthesis methods are co-precipitation, hydrothermal synthesis, thermal decomposition, microemulsion, soljet. Second, nanofluid preparation of nanofluids involves the suspension and dispersion of nanoparticles into the base fluid prepared by using one of the previously described techniques. The combination of the poly and hybrid magnetic nanofluids used in our work were made in two steps. First, magnetic nanoparticles had been produced through smashing the magnetic light metals, iron oxide, nickel ferrite, and ferric oxides. Table 3 and 3 included the chemical composition of every single magnetic nanoparticles. Ultrasonation method, the magnetic nanoparticles were produced using a high energy roller, crusher smashing process, example space side. The most common method after mixing the nanoparticles with the waste fluid places in ultrasonic systems, increase the stability of the magnetic nanofluid. Prevent the accumulation of the nanoparticles in the bottom. Ultrasonication is the act of applying ultrasonic sound waves of frequency 20 kilohertz to aggregate the nanoparticles into the base fluid. This study includes 3 experimental setups. Firstly, heat exchanger systems and 2-phase natural convection thermal systems, heat pipe, and air-to-air heat pipe heat exchanger systems. The air channels directed to the cold air as well as hot air streams were unmixed, which that indicates even lesser gas could be employed for heating recovery. Result and discussions. Parallel flow heat exchangers results. It is mainly depends on the working fluid temperature variance and cool fluid temperature variance. Hot fluid, the system was constant and equal to 7 liters per minute. The maximum enhancement of the overall heat transfer coefficient was 34.5% at 7 liters per minute. When the working fluid was iron oxide nanofluid. The maximum improvement in the surface heat transfer coefficient was similarly iron oxide. And the maximum enhancement in the surface heat transfer coefficient was about 43%. Also, when the working fluid was iron oxide nanofluid. Counterflow heat exchanger results. It is mainly depend on the working fluid temperature variance and cooled fluid temperature variance in this figure. The highest enhancement of the overall heat transfer coefficient was 37.1% at 9 liters per minute. This system, while the average enhancement was about 21.7% for the rest of the system flow rates. The maximum surface heat transfer coefficient improvement was 37.1% for iron oxide nanofluid compared to distilled water. However, the maximum enhancement was 70.3% compared ferric oxide nanofluid. The maximum enhancement in the surface heat transfer coefficient was about 11.9%, system equal to 5 liters per minute. The 2-phase natural convection thermal submersion system conclusions, results and conclusions. The wall temperature is high temperature area, the lower the are compared to others. Thermal resistance decreases with the concentration ratio of both regular and hybrid magnetic nanofluids. General conclusions, firstly, using iron oxide nanofluids and ferric oxide nanofluids, magnetic nanofluids, as a working fluid increase the performance of the heat exchangers. The performance of the system estimated according to the overall heat transfer coefficient ratio and surface heat transfer coefficient ratio of cold and hot streams. The maximum amount of the overall heat transfer coefficient ratio, iron oxide nanofluids, the maximum amount of the surface heat transfer coefficient ratio in the hot stream was 1.8 and 1.7 heat exchangers respectively. The maximum value of the surface heat transfer coefficient ratio in the cold stream was 1.15 and 1.17 heat exchanger systems respectively. The maximum enhancement of the performance heat exchanger systems was about 38 approximately and 28 respectively, when the working fluid in the system was iron oxide nanofluids. The maximum enhancement of the performance heat exchanger systems was about 34 approximately 21 respectively, when the working fluid in the systems ferric oxide nanofluids. The performance of the heat exchanger systems was enhanced by increasing the value of the absorbed by cooled fluid, causing a rise in the temperature of the hot fluid due to the metal oxide's ability of absorb heat. The unique feature of this research is the establishment of steady and high heat conductivity by using iron oxide and ferric oxide magnetic nanofluids. Thank you very much.
Ee, 16'ya kadar çay ve dinlenme molası değil mi? Teşekkür ederiz katılımlarınız için. Saat 16'da görüşmek üzere. 16:20'de benim ayrıca bir sunum var. Yani artık siz bana soru sorabilirsiniz. Ben oraya geçeceğim. Katılmanızı tavsiye ederim. Önemli lazer yüzey kaplama konusunda yaptığım çalışmayı sunacağım. Görüşmek üzere. Sağ olun. Teşekkürler.
Biz nereden katılıyoruz? Anne kız beraber mi geldi? Nereden katılıyorsun? Hangi yerden geldi? Katılıyor. He? Katılıyor. Nereden? Oh, sorry. Where do you come from?
Georgia.
Georgia, and I'm from.
No.
You I didn't have time for it.
fazla gitmeyecek.
Var. Evet, evet.
Ben de böyle bir şey. Uğur'u bir zoomlasana. Çok karanlık. Kendisi de karanlık zaten. Karanlık. Görüyor musun?
Dear guests, I warmly welcome everyone for the afternoon session of International Conference on Advanced Material Science, Engineering, and High-Tech Device Applications. I'm opening the afternoon session at Ankara Hall. So our first presenter is Utku Doğan, and with his study named Open Hole Tension Test and Finite Element Method Simulation in Polymer Matrix Composite Material, Experimental and Analytical Comparison. Please welcome.
Welcome everyone. Hello. Okay. Today we are going to talk about our project, which is the open hole tensile test of the composite materials by comparison of the test results and the experimental results. The writers are me, Utku Doğan, Stefan Şahin, Enes Karakuş. First of all, we would like to start with the composites in the aviation industry. As you can see in the figure, the Boeing 700 X-78 aircraft made half of this aircraft made by the composite materials. So in the aviation, composite materials are highly using day by day. There is some reasons why the composite materials are used. For example, one of the main reason is the lightweight if we compare with the other materials such as steel. And not just the weight, also the strength over weight ratio is important for composite materials. Also, there are some reasons, for example, corrosion resistance, fatigue, or design flexibility. So why we choose the study for the open hole tensile test? Because in the aircraft there are thousands of the holes, different types of holes. For example, the maintenance holes, or fastener holes, or assembly holes. We have to figure out if these holes affect the aircraft stability, structural stability. For this reason, we try to solve this, study this subject. Because, like I mentioned, the structural integrity is one of the important things, and other one is the stress concentration. If these holes, for example, the assembly holes along the pathway, load pathway, that occurs a stress concentration, and this will cause the failure, main failure. So, first of all, I would like to start with what's in the R scope. We designed the ACTM test, and we do this test, and after this we modeled our test, open hole tensile test, and then we validate our model, and then we compare with the test results. After this, we validated, and this validation will be in the next slide. These are the comparison results, for example. This is our scope. First of all, we would like to start with what is our material and methods. We choose the Hexel company's carbon fiber reinforced material, which is named IM712K. We have three orientation stacking sequences. All of the specimen geometric data are the same, but first stacking we have less than thickness than other ones, because there is 16 slides, other ones have 20 slides. This causes the thickness difference. As you can see, this is our isometric view for these three different stacking sequences. So, test and methods that are the content.
Today, I will tell you about test methods that we use and results that we obtain. As you can see
For the mechanical test method, we use Instron Universal Tensile Test Machine. This test machine works with EMB standard and calculated process speed was 1.27 millimeters per minute. This also comes from the standard. You can see a picture of it here. And also, you know that the stress value is calculated by applied force divided by the cross-sectional area, longitudinal force by the cross-sectional area. For numerical simulation, we use LSTime software, and also for getting better mesh quality and better geometrical shapes, we also use HyperMesh program. Also in this page, you can see our material mechanical properties. Overview of our result by applying the simulation and our experimental data, comparison of experimental data with our simulation result, we obtain a great overlap, very similar result. I will explain in the following slide. As you can see, schematic view of our aim. First, you can see force displacement graphic. In this graphic, for our three different orientations, quasi-isentropic, soft, and hard material. As you can see, red lines for our simulation result and the green ones our test result. We get very similar result on soft orientation. Also in the table, you can see the numerical values on experimental result and simulation result for quasi-isentropic hard and soft material. As I mentioned before, we also make digital image correlation DIC method. In this photos, you can see before fracture, after fracture, and initial image of our specimen. Same as the previous page, quasi-isentropic, soft and hard material, and on simulation we observe the same fraction angle and fraction mode. As you can see, very similar result. And also we want to write possible reasons for the difference between these results. Finally, in this page, there is a one graph and one table, and these are the first graph and table. As you mentioned, three specimens with one table and graph. You can see for the hard material is best capacity on strength because of the fly degree. There's a lot of 0 degree fly, and we also said that longitudinal force applied on the spiral direction. Also in the table, there is also a numerical table, and this table you can see the change rate of the percentage change rate and regards the order of importance of change in whole size in this table. And finally, the extra additional result. In this table, we count this table, and this table tells us the difference between tensile and maximum principal stress is at some point for minimum, and if the minimum point is different for all three orientations because of their composites and they have different strength parameters and mechanical properties. We can say that according to this table, at minimum points there are very less difference. So at this point, at this whole diameter, our material will act like fantastical behavior or homogeneous behavior. We can say that because there's a very difference between tensile and maximum principal shear stress are differences. And finally, we would like to thank the Tutaş family for providing us with all laboratory and other facilities. And also, we'd like to thank our supervisor, Professor Mete Bakır, so all this help throughout his work. Thank you for listening.
Thank you very much for your presentation. Is there anyone who would like to ask questions regarding this topic? Please, go ahead.
Başlangıçta bir oryantasyonun etkisini gösterin dedim işte 0.90, eksi 45, 40 vesaire. Sonra da hol diametrisinin etkisini sundunuz. Burada kaç cümleyle bu oryantasyonun etkisi nasıl oldu şeklinde bir soru sorsam.
Yani o anladım ben istediğimde. Yani o grafiklerin hepsinde aslında numerik kabloların olduğu yere birazcık hızlı geçmiş olabilirim. Biz o dediğiniz hani özellikle delik çapının etkisini öğrenmek için aslında delik çapının uygulanan kuvveti aynı tuttu. O yüzden zaten farklı sonuçlar elde ettik. En sonda dediğimiz oryantasyonun etkisini gözlemlemek için o en son gösterdiğim üçünün bir arada olduğu tabloda da bu sefer de delik çaplarının aynı oranda değiştirdik ama işte yüzdelik olarak farklı bir sıralama gördük. O sıralamada işte hani yine bahsettiğim hani 0 derecenin çünkü hani bulunmamasına bir kuvvet uyguladığımız için hani o derecenin çokluğundan dolayı gelen bir farklılık oluştu.
Yani sequence dizilim etkili yani o açık bir etki. Ama sizin burada çok herhalde ona durmadınız ya da sunumlarda şey.
Biraz daha da bahsetmiş olabilirim aslında. Son bütünün bir arada olduğunda
Slide'a dönme şansımız olabilir mi? Sayın Reji.
Yani dizilim mukavemeti nasıl etkiledi? Siz bunu holden bağımsız da yapabilirdiniz. Yani direkt o dizilimin etkisine de bakabilirdiniz. Yani 45 derece ya da eksi 45
Yok, bu slide değil, Utku Doğan olan slide.
Birkaç cümle söyleyebilirsin. Yani beklentiniz nasıl? Yani bu unidirectional olması ya da 45 derece olması ya da 0.90 olması.
Aslında şöyleydi, biz ASTM standartına baktığımız zaman bu test için bir tane standart bir delik çapımız var. Galiba 5.4'tü, şu anda tam hatırlamıyorum. Ama bu standart sadece bu bizim quasi isotropik dediğimiz, şuradan ben açayım adamını. Kapandım.
Sizler Yazılı Beyazıt Üniversitesi'nde misiniz?
Evet.
Orada metalurji mi?
Makine mühendisliği.
Makinede deneylerinizi TUSAŞ'tan mı?
Evet, TUSAŞ laboratuvarlarında lik Tamam, orayı ben açayım.
Şimdi bak şu o deminki sequence'e gel, o dizilimden. Şimdi burada bir dizilim vermişsiniz. Yani işte 45.0, eksi 45.90 ve bunları belli aralıklarla da dizmişsiniz değil mi? Yani
evet, bu sekans
bunların bir etkisi olacağı kesin. Yani
tabii ki, evet.
Çünkü gerilimin orada dağıtıyor. Yani 90 olmakla, 0 olmakla, 45 olmakla gerilimi dağıtıyor. Bir de bunları ayrıca hol yapıyorsunuz. Doğru mu?
Evet.
Peki holsuz çektiniz mi hiç kıyaslama?
Yok, öyle çalışmak. Sadece open hole tensor dedim. Delikli numuneler üzerinde çalıştık biz.
Anladım. Yani sırf şu dizilimlerin mekanik özellikleri etkisiyle incelemek bir yayındır, onu söyleyeyim ya. Ve şeyiniz neydi? Karbon fiber'dan bahsediyorsunuz.
Evet,
hep karbon fiber.
Evet, malzememiz aynı, o değişmiyor. Evet, ben hemen şurayı açıyorum. Burada bizim yaptığımız araştırmalarda ASTM standartında delik çapının 5.4 olduğunu ve bunun da bu turuncuyla gördüğünüz quasi isotropik dediğimiz numune için geçerli olduğunu gördük. Ama biz bu oryantasyonu değiştirdiğimiz zaman, örneğin bizim SDT dediğimiz daha çok 0 derece değil de 90 derecelik fiberlerimizin fazla olduğu veya HRD dediğimizde de 0 derecelik fiberlerin fazla olduğu numunelerde bu delik çapının hani değişip değişmeyeceğini aslında biz bu çalışmada göstermeye çalıştık. Yani yaptığımız çalışmalar sonucunda da bizim bu diameter between tensile principle ve bizim çekme mukavemetlerimizin karşılaştırılmasında da aslında bunun değiştiğini farkına vardık. 3 farklı oryantasyon içinde optimum delik çapının değiştiğini fark ettik. 5.4 dediğimiz quasi izotropik için geçerliyken biz farklı bir stacking yani dizilim gösterdiğimiz zaman da bunun değiştiğinin farkına vardık bu çalışmayla aslında. Minimum noktalarda. Birinde 8 küsürlerdeyken diğerinde 10.5, 11 civarında. Hı hı. Evet. Hı hı.
Şimdi biz standartında koordinat için yazılmış. Biz aldık bu standartı bayağı iyi inceledik. Ve orada 5 noktadan demiş. Hatta bu simülasyonun doğruluğunun kanıtı niteliğinde.
Burada deniz
Yok, burası simülasyon. Evet. Burada simülasyon yaptık yani. Hani simülasyonda bu farkı yazdık ve hani malzemenin elastiği yapılı özellik gösterdiği kırılma noktası delik çaplarını bulup ve bunları da optimum diyebiliriz dedik. Çünkü hani standartta da koordinat için 5.4 gibi bir delik çapından bahsediyoruz. Yani sanki kompozit malzeme değil de homojen gibi. Hani sanki eski şekline geri dönebilir gibi yani o açıda.
Ben çalışmamızda da deneysel değil mi şunlar? Bu deneysel
Evet, bu testle karşılaştık.
oryantasyonlarını getiriyor. Diğer tüm geometrik özellikleri bu da zaten kendisini gösteriyor. Besman bir kitap aldım. Burada devrin gibi savaşlar. Evet. Aslında bir kuvvetli değişiyor. Bir de
Bir teşekkür ederim. Zaman kısıtlamamız var. We would like to thank the presenters. Now I would like to invite Professor Mehmet Eroğlu with his paper named Effect of Wolfram Carbide Addition on Ferroboron / Wolfram Carbide Laser Composite Coating. Professor Eroğlu, you have 15 minutes.
Thank you very much. My name is Mehmet Eroğlu from Stanford University. I'm working on in the metallurgical and resistance and research department. My working subject property, microstructure, ballistic materials, etc. But mainly I can say that surface coating.
This results from a project supported by GÖK and University Cooperation. The content short introduction, then experimental study, results and title, and conclusions. What's the importance of this subject and of this study? The surface coating is important for corrosion resistance, wear resistance, to protect the surface of the material, and even this process is cheap. For example, if you wanna do for corrosion resistance, you don't have to choose the material just only stainless steel. On behalf of this, you can use low carbon or carbon steel, and you can do surface coating with high chromium powders, wires, etc. When we are doing this, you can use some different kind of methods, such as arc welding, powder spray methods, and laser welding.
Laser welding is the most important nowadays because it has many advantages. Low heat input, low dilation, low heat affected zone, etc., etc. So the laser method, laser surface cladding or laser surface coating method is increasing sharply. I think in a few years later, we will not see the conventional welding methods, such as coated electrodes, teeth, MIG-MAG, etc. Actually, laser welding and surface coating is increasing, and it will be used most areas. We have time. I'm passing this quickly. In laser surface coating, we are using powders and wires, I said. And we classify this kind of powders in three mainly groups. These groups contain iron-based, nickel-based, cobalt-based powders or wires. To increase the resistance to wear, we can add some different kind of ceramics powder to this kind of powders, such as wolfram carbide, titanium carbide, niobium carbide, or nitride, borides, etc. We can use some ceramics to increase the hardness of the surface using with this kind of powders. And we can make composite coatings like this. The importance of our study is in the first time we produced iron boron alloy powder, and we got patent on this subject actually. The main idea is to decrease the melting point of the powder. So if we look at the iron boron equilibrium diagram, phase diagram, we can see that 3.8% boron and the rest is iron give us eutectic point. Roughly 1,150 or something like that, something like Celsius. So this temperature is low actually, if we think about the iron-based powders. As I said in the literature, first time we produced this powder under this project. And then we blended this powder with the wolfram carbide, or tungsten carbide, anyway, the same. Then, using this mixture powders, we coated a low carbon surface using laser heat source. And then after finishing coating, we investigate the microstructure, weave properties. Then we concluded that which alloy or which mixture is better, give most better results, etc. We can see at the end of my presentation. You see, this is the base plate or parent metal we are saying in the welding. As you see, there's a low carbon steel, ST37. And then this is the Poldo SEM macrograph of FB eutectic alloy. As you see, the very spherical. And the size range was between 50 and 150 backgrounds of this powder, and chemical analyze, as you see in on table 2. As you see here, the boron is 3.8, and there is some chromium, carbon is low, and the manganese is nearly 1 or 1.9. And then the rest is the iron. So this is the cheap powder, as economical one, because no additional alloying elements, expensive elements, there's no expensive bit. We see the mixture of the powders. As I said before, after producing iron boron powders, the mixture, we have done mixture with the wolfram carbide powders. You see the ratios on the table. The first one, S1, no wolfram carbide, tungsten carbide. The S2 one, 5%, 10%, and 20% content wolfram carbide. After mixture powders bonded to the surface with the PVA polymer sample in 4 millimeter thickness, and that laser melting process were performed. 3 millimeter per second scanning speed and 1.6 kilowatt laser powder were used in laser melting laser surface coating process. After finishing the laser coating, samples were taken out for macrostructure examination in the coating area, and these were subjected to necessary blending, polishing, then etched with 3% nickel polishing. Then images of the samples were taken under SCF at different magnification, and micro-analyses were performed with the EDX. In addition, XR analyses were performed. And also we got micro hardness with the 200 gram. And you see the schematic representation of laser clouding. As you see, you see the off-focus length here, and we replace the fountain, as I said. Then after drying, then laser melted the replaced powder, and solidification area is here, and we can say this is a coating or cladding part of the material. We can say that. This is my laser in my laboratory, 2 kilowatts fiber laser. Şuradan böyle üstüne basıp oynatması lazım. Resmin üstüne tıklayabilir miyiz video çalıştırmak için? Reji. Resmin üzerine tıklayabilir miyiz videoyu oynatmak için?
Olmuyor mu? Olmuyormuş.
Olmuyor.
Olmuyormuş.
Yok, çalışmıyor.
Peki. This is my basic learning machine, but I'm using here for learning. So actually this is learning machine. But I use this for coding. Here, the single pass coding macro structure, raster structure actually. You see, very smooth, more or less no how that's actually it was they were good. And for sliding test, we changed the dimension of the specimen because we had to use bigger size for getting X-ray analysis and rear test. We used for this 20 millimeter multiply 20 and 10, and 50% overlap has been done. This is the bigger size specimen, multi-tracks. Here is results, macrostructure, SCM macrostructure, SCM micrograph. You see on the left side, here is the line, vision line, this is perimeter, this is coating or cladding, this is bigger macrographs taking for coating. You see, we see the primary phases here, the dark one. This is at the beginning of the solidification. These areas are austenite. Then, after solidification, this transforms to perlite, and the area between the areas are eutectic. Means two cases, F2B, iron boride, and ferrite or cementite or perlite mixture here. Here is the S2 specimen macrographs. You see here wolfram carbide and the eutectic area and the primary phase perlite. Here is S3. You see also wolfram carbide here, some solution here. And the other one is S4. The same mechanism is working here. Then the wolfram carbide, some parts are dissolving under the heat of laser and making deep compounds around the wolfram carbide. Yes, as we see on pictures, the macrostructure consists mostly of perlite and eutectic. Eutectic also consists of F2B, ferrite, cementite, perlite mixture actually structure. This situation can be explained as follows.
as you see, at first we use eutectic FB alloy, but under the laser heat, some iron comes from base metal, and eutectic goes to just projectile, actually. And sample 2, 3, and 4 also exhibited similar matrix microstructure as one. As can be seen from this microstructure, wolfram carbide powder passes into coating, so no problem. The X-ray results taken from the coating are given figure 3 and as representative example of the EDX analysis. The EDX results obtained from sample 4 are given figure 3, table 3, and table 5 respectively. Let's see them. You see the X-ray graphs, XRD graphs.
Professor Verola, I would like you to speed up a little bit.
All right. You see FTB, wolfram carbide, F wolfram carbide, new alloys, and the boron type, FWB, alpha, iron, F3C. We can see the peaks of the bone graphs. You see EDX results on the wolfram carbide. Here the only one of the wolfram and carbon here. But near here, you see, as I said before, wolfram carbide is dissolving under the heat of laser, and new compounds are forming here. You see the analysis of it. Yes, hardness results are giving on table 6. You see this 640 no wolfram carbide inside. That's a good hardness actually for only FB powder, iron boron powder. That's a good hardness actually. That's we can say high actually. So when we add the wolfram carbide inside the iron boron powder, the hardness increase, as you see here. So this is base metal hardness. You can see at least 3 or 4 times hardness is increasing. As we see, dry sliding wheel results. Here, wheel volume loss values of specimen. The volume loss is increasing with the load, and the friction coefficients values are decreasing when we increase the wolfram carbide. You see one example of TOI values. So conclusions. In this study, FP-based powder was produced and low carbon steel was coated with the laser beam by adding wolfram carbide powder to the powder in different kinds of ratios. As a result of experimental study, the following conclusions can be reached here. Coating with FP-based powder, the coating microstructure consists of hairline and eutectic structure. Coating speed with the FP and wolfram carbide powder mixture. Wolfram carbide passes into coating and this partially dissolved. FP-based powder increased hardness and wheel resistance. Adding wolfram carbide powder to FP-based powder could increase the hardness and wheel resistance. The maximum values of hardness and wheel resistance were obtained at 20% wolfram carbide. FP-based powder and wolfram carbide mixed powder can be used effectively in the industry
by laser, we can say that as a result of this study for practical application.
Thank you very much. Congratulations on your study and your patent. We can have time for one quick question, if you have any. Okay. Thank you very much, Professor. Okay, we are not gonna fall behind on schedule. Arkadaşlar plaket durumu nedir? Bunu arkaya verebilir miyiz?
Hadi plaket Photoshop'la yaparsın.
Bu değil de.
Plaket takım çıkar. Photoshop'la yaparsınız.
İlk sayfaya girelim. Teşekkür ederim. Now I would like to present Professor İdris Tuğrul Gülenç with his paper named Manufacturing of 7075 Aluminum Alloy and 316L Stainless Steel Layered Composite via Explosive Welding. Professor Gülenç, you have 15 minutes.
Thank you. Changes to Hello everyone, thanks for coming today to my presentation. So my talk is titled Manufacturing of 7075 Aluminum Alloy and 316L Stainless Steel Layered Composite via Explosive Welding. So my name is İdris Tuğrul Gülenç. I'm an assistant professor at Ankara University Department of Metallurgical and Materials Engineering. So, okay, get back to the just a second. Okay, here's my outline for my slide. So I will talk about our motivation, why do we need to do such study, and I will talk about how we did this study and the microstructural observations we had, hardness changes, and because this is an ongoing study, what are the future directions for this study? And of course, I will close with the conclusion. So let's start with motivation. Explosive welding is a method which can be used to join dissimilar materials, and it's a solid state welding method. Normally, these dissimilar materials cannot be welded together, but so explosive welding, or we can call it explosive cladding as well, can be used to join dissimilar materials.
So aluminum alloy 7075 is a high strength aluminum alloy, but still it's an aluminum alloy. So the maximum hardness we can reach is limited. So by combining this aluminum alloy with a harder stainless steel, we can increase its strength and ballistic performance and all other application areas. So this is the main motivation to increase the strength of the thick aluminum panel. So how explosive welding works, let's start with this. So firstly, by the way, explosive welding, we don't need any binders compared to other methods. Normally, we need some binders, and the strength of the binder identifies the quality of the joining, but the explosive welding, we don't have any binders, so our material strength depends on the main material strength actually. So for this method, we are placing our backing material. This example, this was the aluminum alloy. It was a thick one, 25 millimeter in thickness, and we placed the cladding metal. In this example, it's 316 stainless steel, and we are putting the explosive here, and we are starting our explosion from this point. And when the explosion started, this solid explosive changed its phase to a gaseous one. Because of the expansion of the gaseous phase, we are creating a jet, and this top plate, flyer plate, hit to the bottom plate, and this creates a solid state valve during the process. So again, with this method, we are aiming to create some reinforced alloys. So reinforced layered composite. How we did this stuff? So you on the top you are seeing the top piece is the coated material, and the bottom piece is the material to be coated. And here you are seeing the explosive, and here is the detonator. So our explosion will start here, and the explosion will not happen all of a sudden. It will follow a linear path. It will start from this point, and it will move through this path. So this will provide coating of the top layer to the bottom one. And here you are seeing a real footage from this experiment while it's happening. So as you can see, it is not a sort of simple experiment. So there are some health and safety precautions during this experiment. So we are taking our distance, and explosion happens, and this is placed on a large cast iron base plate for the process. So different explosive ratios were used for these claddings. One of the explosive ratio is the ratio of explosive to the top flyer plate. Stainless steel in this example, we use 1.5, 2, and 2.5 explosive ratios. And cladding samples were cut perpendicular to the explosive direction. And a particular electron microscope analysis were performed on edge samples, and hardness is used to evaluate mechanical properties. And as I said, this is an ongoing study. I will explain what we are aiming to do further. So the composition of the materials are given here. So the important bit for us here is copper content and magnesium content. These are relatively high content for aluminum part, and zinc as well. And for this stainless steel one, we don't see the molybdenum is the one we may expect to see, but the aluminum part is more important for us for this example, and actually I will explain in a minute why. So here are the optical images of three different explosive ratios. So the bottom piece does not belong to this study. This is a study from the literature. You can find the details of this study. I gave this example because you can see a significant difference between the bottom one and the top one. Normally, with explosive welding, when we are coating thin materials, relatively thin materials, or with materials with similar thickness or similar hardness, we see with increased explosive ratio, this is 1.5 explosive ratio, this is 2, and this is 2.5. So with increased explosive ratio, you are seeing interface is sort of having higher wavelengths. But with this example, we don't see such phenomenon here. We are seeing, so this is the interface, but we are more interested in the aluminum part. This is the aluminum part, and this is the interface part. So we don't see that much wavelength. And if you check the 500 micron scale bar and 100 micron scale bar, you can see the difference. We should be able to see even more wavelength, but we can't. Something different happened here. For this example, our base plate is much more thicker than the flyer plate. So the base plate, the aluminum part, this part is 25 millimeter in thickness, but the top one is 1 millimeter in thickness. So, and the bottom one is much more darker. When this happens, rather than seeing the deformation of wavelength on the interface, this time we saw the wavelength in the material itself. So here we are seeing the less waveless in the material with low explosive ratio. But if we increase the explosive ratio, we are seeing higher wavelength, and with the highest explosive ratio, we are seeing much more high wavelength. So when we are joining these materials, we saw much more different microstructure than the conventional one, and this caused a change, deformation in the microstructure. So the question arrived after this point was, is it because of the segregation or something chemical, or is it just because of the grade? So to understand this, we also did some EDS analysis, line scans, just to see if these different bands, because you are seeing some contrast change here alongside this thickness. So we wanted to understand what is the reason of this contrast change. So we did this some linear EDS scans to understand what's happening. And again, this is the aluminum one on the bottom one, and we are seeing the little bit portion of this silver. And of the EDS analysis, by the way, you can see the continuous interface here. So there's no voice, no gas. The only voice we can see are arising from the etching process. And with the line scan, this is the point when we are switching from aluminum to stainless steel, because we are seeing more polarized signal at this point. So things we may associate with these white bands could be different chemical compositions. So this could be copper or zinc or magnesium. So we are saying this can't be copper or zinc. So these bands, they are not visible with electron microscope. They are more visible with optical microscope, but electron microscope is used for EDS analysis. There is no relationship with copper and zinc, because we can still see the copper on steel parts, so we can make any relationship between copper, zinc, and these bands. There are some sort of magnesium effect, but this is not that much strong again. So this tells us these bands happen because of the deformation and different alignments of grains, so different aligned grains etched differently, and these created the contrast in this image. So there is nothing with the chemical segregation in this example as expected, because this is a solid state welding process. We can only expect to see limited welding at the melting at interface, but typically we don't expect to see this. And this happens again here, and here in this example we are still in magnesium signal even with the steel one again, so we can't associate any elemental change, copper, zinc, or magnesium with these bands. So these are showing these are changes associated with the deformation and the crystal orientation. So the hardness change. So this is the interface. This is the aluminum side, and this is the steel side. So we are seeing lower hardness for the aluminum side. But as we getting closer to the interface, we are getting a slight elevation of the hardness. Normally, we just see a slightly higher increase of the hardness, but in this example, it's a lower. Again, probably because of the thick plate, I believe. And on the stainless steel part, this change is more significant. So we are seeing a high increase as we going close to the interface. So the main reason for this is because of the plastic deformation. So because of the crash of the top level to the base plate. Because just remember, please, this video here. So there's a quite huge explosion there. So the speed of the flyer plate is quite high. So because of the impact effect of this explosion, you will see here plastic deformation happens. And when this is happening, this top plate just hit to the bottom one, around this region. But again, as I said, in the aluminum side, this is probably because aluminum is too much thicker than the typical joining we are using the explosive valve. So what to do further, because this is an ongoing study. So we need to understand the microstructure in a better way, because there's a plastic deformation happening there, and there's a crystallographic texture change is happening. The best analysis we can do right now is EBSD analysis. EBSD, probably we are hoping EBSD will give the best result for the texture formation. So what is the texture change before and after cladding process? So EBSD is the first step we want to achieve, and also the EDS one. The electron microscope we use can't go too little resolution step size. So we are aiming to use a finer resolution step size to resolve these bands better if there's a segregation reason for this. But again, this is not likely, but we should check it. And also, nanoannealation is planned because we can resolve, because with these hardness measurements, these are micro hardness, because we have to have a certain gap between individual indents. We can't go any closer than this. We can work also with steel ones because they are smaller, built harder, we have small indents. So to resolve this change and to be closer to the interface, we will try to use non-annotation to see the interface further. So to conclude everything, these alloys can be joined successfully and without any additive of the binder, we can achieve quite good joining. There's no void, no gaps in the interface. So the strength of the 7075 alloy can be increased just by adding a little bit stainless steel mass reduction addition. So we can still have the lightweight aluminum alloy here. So I would love to hear if you have any questions. Thank you.
Thank you for your presentation, for your interesting presentation and your quick delivery, I would say. I have a little question that while we're performing explosive welding, do you follow any standards regarding which dissimilar metals are weldable or which parameters, how much gunpowder should I use, how much thermite should I use?
Well, we are following our experiences actually. But nearly all metal couples can be welded, explosive welding, nearly all of them. But there are, of course, a guideline in the ASTM handbook for welding in explosion welding section. And for the explosion ratio, 1.5 to 2.5 ratio, I mean the ratio of the weight explosive to the fire plate. Most of the time, it's better in this range, but there is no other standard best my opinion, best my knowledge.
Thank you very much. Any questions? Okay. We would like to thank İdris Turul Gülenç for his presentation. Thank you. Now, I'm inviting Feyza Sarı for her presentation about microstructural and mechanical analysis of hard-phase surfaces using a novel self-shielded flux-core arc welding wire. And with her, Can Yılmaz is also coming. You have 15 minutes.
Herkese merhaba, ben Feyza Sarı, Gezi Kaynak'ta Ar-Ge mühendisi olarak çalışıyorum. Bizim bu çalışmamız gazlı sert olguları, gazlı örgü telleri, sert kaplamalar üzerindeki mekanik ve mikro yapı incelemeleri üzerine. İçerik olarak bu projenin amacını sert kaplamaları, üretim sürecini, kaynak performansı, mikro yapılarını, farklı aşama testlerini ve sonuçlarını inceleyeceğiz. Yedi kaynak bünyesinde yapılan yatırımlar ile birlikte yapılmış ürünlerin TÜBİTAK tarafından fonlanmasıyla birlikte bu çalışmada gazlı sert olgu özlü teller üzerine çalışmalar yapılmıştır. Bu çalışmada 85-55 standartını karşılayan 2.4 mm çapında yeni geliştirilmiş bir sert olgu üzerine çalışmalar gerçekleştirilmiştir. S355 çevre plakaların üzerine 300 ve 400 amperlerde çalışmalar yapılmış ve bunların mikro yapı ve mekanik incelemelerine bakılmıştır. Çalışma sonucunda sert olgu kaplamalarının performans hakkında önemli bilgiler sunmakta ve yeni geliştirilen kaynak teriminde istenen mikro yapısal ve mekanik özellikleri etkinliği vurgulanmaktadır. Sert olgu nedir? Makine ekipmanlarının arızalarının %50'sinden fazlası aşınmalardan kaynaklıdır. Bunların da %20'si adresif aşınmadan kaynaklıdır. Sert olgu alışma direncini arttırmak ve bozulan yüzeyleri eski haline getirmek amacıyla sert metal katmanlarının üzerine nispeten daha düşük ana metallerin üzerine kaplama yapılarak çalışmalar yapılır. Uygun maliyetli bir yöntemdir. Kaynak düşük kurulum maliyeti, geniş kullanılabilirliği ve yerinde uygulamaları ile kullanımı son zamanlarda artmıştır. Sert olgu uygulamaları alanında gazlı sert olgu özgürlüklerin özellikle aşınma nedeniyle tehlikeye giren bileşenlerin onarımı ve kaplanması üzerine çalışılır. krom, karbon, niyonyum, molibden gibi alaşımlama üzerine çalışmalar yapılır. Nikel ya da kobalt alaşımlı tellere kıyasla demir bazlı demir, krom, karbon, demir, karbon, bor gibi uygulamalar çelik sektöründe, aynı zamanda tarımda, çimento üretiminde, termik santrallerde kullanılmaktadır. Üretim sürecinden biraz bahsedeceğim. Ana metal dediğimiz düşük karbonlu, düşük alaşımlı S355 üzerine kaynak 2,4 mm gazlık sert dolgu özlü telleriyle kaynak işlemi gerçekleştirilmiştir. Bu 185-55 normunda karbonu 5, yüzde 1,5, manganı 1,3, kromu 27, demiri ve geri kalan da demir olacak şekilde standartı karşılamaktadır. 3 pası halinde ana metal üzerine 300 amperlerde ve 300 amperde ve 400 amperde iki çalışma yapılmış ve bu pasolar arasında sıcaklığında 150 derece olacak şekilde ayarlanmıştır. Daha sonra numune işlenmesi için 0,6 mm yüzeyi işlenmiş. Daha sonra metalle dağlanıp kıraltıyla dağlanmıştır. Daha sonra sen görüntüleri, mikro eti için sen görüntüleri alınmış. Viker sertliklerine bakılmış. Daha sonra farklı dereceye çevrilmiş. Daha sonrasında ise aşıma testleri yapılmıştır. Gazsız sert dolgu tellerde BD03 düşük alaşımın saçla birlikte %44 öz oranında çalışmalar yapılmış. Bu çalışmalar sonucunda üretim sürecinde herhangi bir problemle karşılaşılmamış. Öz akmaması, burunun kıvrılmaması, saçın kopmaması gibi herhangi bir problemle karşılaşılmamış. Kaynak performansı ve kaynak dikişine de herhangi bir problemle karşılaşılmamıştır. Sert dolgu kaynaklarında ABS-A521'de de belirttiği gibi kaynak metalinde gerilim azaltma sağlayan çatlaklar gözlemlenmiştir. Şurada da oklarla gösterdiğim gibi. Daha sonra mikro yapıları incelenmiş. Bu A numunesi 300 amperle yapılmış, daha düşük ısı girdisine sahip, hızlı soğuması nedeniyle A numunesinde daha ince densitlik yapılar gözlemlenmiş ve açık renkli fazla krom karbon olduğu ve bir miktarda krom 23 karbon 6 olduğu mevcuttur. Koyu renkli yerlerde o gösterip koyu renkli matriste östeliktir. Markan hızlı soğumadan kaynaklı yapıda markan oluşabileceği düşünülmekte, fakat isterdi analizlerinin incelenmesi gerekmektedir. B numunesinde densitlik ve karbon oluşumlarının daha dağınık ve daha büyük olduğu gözlemlenmiş. Bu da daha alt homojen bir dağılım olduğunu göstermektedir. Daha büyük densitlik yapılan sertliğin azalmasına ve ışınlanma azalmasına sebep olacaktır. Daha yüksek ısı girdisi, daha yüksek ısı girdisi nedeniyle daha yavaş soğuma hızı muhtemelen de daha iri krom karbon yapılarının oluştuğunu, çok da az miktarda krom 23 karbon altının oluştuğu görülmektedir. Sertlik testlerine baktığımızda ana metalin sertliğinin 18 derece olduğu gözlemlenmektedir. Her numunede yüzeyden ana metale indikçe sertlik değerinin azaldığı görülmektedir. Bunun sebebi de yüksek alaşımlı kaynak malzemesinden düşük alaşımlı sünek ana metal arasındaki sertlik farkından ve de kaynak sırasında meydana gelen seyrelmeden kaynaklı olduğu düşünmektedir. A numunesinde daha ince krom karbon yapılarının ve daha iyi dağılmış bir krom karbonların olmasından kaynaklı A numunesinde daha iyi sertlik sonuçları, daha yüksek sertlik sonuçları alınmıştır. Aşıma testleri incelendiğinde burada kaynak mesafesine bağlı olarak sürtünme katsayısı değerlendirilmiş. Aşıma numunelerinin çok ağır olduğundan kesip alamayacağımız için mümkün olmadığından ağırlık kaybı hesaplanamamıştır. Bizde sürtünme katsayısıyla aşınma direnci yüksek olan malzemelerin doğrudan bir tuhaf olma doğru olmasa da aşıma direnci yüksek olan malzemelerin sürtünme katsayısının daha düşük olduğu söylenebilir. Aşıma testleri aynı koşullar altında yapıldığı gözlemlendiğinde ağır ve numunesinde A numunesinin aşıma direncinin daha yüksek olduğu görülmektedir V numunesine göre. Sonuçlara bakacak olursak, genetik kaynak bünyesinde yeni üretilen telleri, lastikler özlü teller incelenmiştir. Daha iyi farklı dağılımına sahip, daha ince taneli mikriyoplar sergileyen 300 amperde yapılmış A numunesinin sertliklerinin daha iri taneli yapıya sahip, daha düşük aşınma direncine sahip B numunesinden daha iyi sertlik ve aşınma direnci verdiği gözlemlenmiştir. Sertlik testleri yüzeyden ana metreye doğru kademeli bir düşüş göstermiş olduğunu ve A numunesinin daha ince karbon yapıya sahip olduğu görülmüştür. Aşınma testi sonuçları A numunesi için daha düşük sürtünme ve daha iyi sertlik aşınma performansı göstermiştir. Bununla birlikte gazlı sert olduğu özlü teli özellikle düşük amperlerde dayanıklı aşınmaya dirençli kaplamalar üretiminde etkili olduğu gözlemlenmiştir. Geleneksel özlü tellere kıyasla uygulanabilir bir alternatif oldu ve harici koruyucu gazlara ihtiyaç duymadan etkili sert kaplamalar yapılabileceği göstermektedir. Gelecekteki çalışmalarda ise performans daha da arttırmak için süreç parametrelerini iyileştirme çalışmaları yapılacaktır. Teşekkür ederim beni dinlediğiniz için.
Is there any questions regarding this topic? Professor Gülenç?
Şimdi oradaki sertlikle 60 küsur Rockwell diye gözüküyor ya. Peki o sertliklerde bir lamel yırtılma şeklinde yani kurcuk taşınma daha çok olduğunu düşünmedim. Bu yani bu soruyu sorarken gedik olduğunu için soruyorum. Yani şahıs olarak sormam da. Burada daha da düşük sertliğe sahip ama daha yüksek mangallı ve çalıştıkça yani başka bir işte darbe yedikçe daha sertleşebilen ve daha aşınma mukavemeti optimum olan şeyler var. Burada ne avantaj sağlıyor? Yani bunun özel bir yeri var mı? Bu dolgunun özel bir yeri var mı? 3 paso dediniz bile. 3 paso yan yana mı? Üst üste mi?
Hocam 3 faktör üst üste oluyor. Burada bizden talep edilen 27 krom 5 karbonlu, hani dışarıdan alttan yaptığımız ürünün muadili olarak bu. Dediğimiz 14 menü aslında ürünlerimizde var. Onun üzerine tam çalışma başlatılmadı. Hani çalıştıkça sertleşebilen 14 manganlı çelikler. Bizden önceki bu alanda çalışmayı istendi, bu kimyasal anlamında. O yüzden bu şekilde çalışmalar.
Yani bu sipariş üzerinde bir çalışma. Yani
Ama böyle hat
ama
yazı
şöyle yani 3 paso üst üste yanmak böyle çok ekonomik bir durum ortaya çıkarmaz ki.
yok. Burada biz 3 fasoda normal hani fazların farkı oluşacak da doğru belli değil. Fazla geçene kadar. Faz değişiminde amperin ana metale göre sertliğini ve aşınma indeksini etkisini aslında incelemiş.
Hocam
Ama
burada
tek faso da yapılıyor, çift faso da yapan var, üç faso da yapan var bunu. Evet. Evet. Müşteriler de genelde iki faso kullanıyorlar. Bize gelen talepler oluyor.
Yani o çok ekonomik bir şey değil ki.
hocam ben burada gelebilirim. Ekonomik değil, zaten Amerikan kaynak standartının istediği bir gereksinim. Yani bunu standarda uydurmak istiyorsanız tek paso ve 3 paso olarak sertliklerini belirleyin diye geçiyor. Bunun da anlamı şu, yani tek pasoda seyrelmeyi görecek, bir pasoda seyrelme olmadan telin kendi sertliğini görmek için aslında.
Yani şöyle pasoyu tarttıkça o çatlaklar daha büyük, daha rekabet düşürür bana göre.
Muhakkak artacaktır hocam.
Değil, aşırı mukavemet düşürdü. Ben mekanik özellikler olarak düşünmüyorum bu konuyu. Aşırı mukavemet düşürdü.
tesisinde kaynak mekanizması içerisinde agresif aşınmaya karşı daha dirençli oluyor.
Vallahi bilmiyorum yaptığımız seslerden olmayacak yanlış yaptık.
Bir noktadan sonra kullanma ve dökülme tarafına kayabilir. Çatlama dedikten sonra. Gömelim İksar denizleri bitmedi. O yüzden net bir şey söylüyorum ama katılıyorum.
Bakalım. 485 karbon var. 27,5 krom var. Yapıda bir miktar bor da var.
Mikroplar özellikle hiç görünmüyor. Kayıp var mı?
Zaten.
Dersinde
Gaz oluşturduğu mutlaka ajanlar var zaten.
Yoksa mesela koyduğu zaman karbon monoksit, karbon
Zaten grafik karbon da var içinde bir miktar.
grafik de var, karbon da var, krom karbon da var. Yani o tabii alışma biraz farklı.
Yani tam kaynakçılar içine düşündüğünüz zaman
Yok doğru değil. Zaten bilerek geldik ya.
böyle affetmeyiz yani.
Yok bilerek geldik hocam.
Ben M23C'de çok da burada oluşacağını zannetmiyorum. Genelde M7C3 karbürler daha çok etkilidir.
Şöyle bu tozaltı metoduyla yapılan bir sistem. Normalde hani 1,6 milimetre formunda bu yapıda kaynak yaptığınızda dediğiniz gibi birçok yapı oluşuyor. Beşgen, dörtgen, altıgen yapılar gibi karbonlar oluşuyor. Fakat gazaltı yapıldığı zaman kaynak makinesinde bazen bir miktar amper voltaj ayarı oynuyor mesafeye göre. O da bir yapılarla katılaşmaya göre bir farklı oluşmuş olabilir. Reklam numara önemli.
Bize bakmak lazım. Yani
Analiz tutsa da dediğim gibi sizin bahsettiğiniz o yapılar farklı çıkabiliyor. Tozaltı makinesinde yapıldığı zaman.
Yani analizin bir ötetik güçlü yapmıyor olması gerekir diye anladım. Ama şeye bakmak lazım. Ben sizin gördüğünüz analiz, elektroda tattığınız analiz. Yani elektrodun
Yok, daha kaynak için anlıyoruz.
kaynak dışı
Kaynak.
orada birinci tabirler, emniyetçiler ve
İri görünmesi lazım. Dediğiniz gibi.
tebrik ederiz yine de. Yani biz bir kişi, siz iki kişi geçtiniz oraya. Hatta üç kişi.
Doğru abi.
Ya soru soracağız tabii ki yani bu gedik olduğu için soruyoruz biz bunu. Ben şöyle söyleyeyim o zaman. Benim anladığım kadarıyla tozaltı kaynağını dışarıda şantiyede kullanamadığı için şantiyedeki kompresör çeneleri vesaire gibi yerlerde içeride olduğu için bir avantaj sağlayacak bir elektrot geliştirmiş.
Aşırma plakaların üretiminde kullanılıyor daha çok. Bunu biz 2,4 olarak tasarlıyoruz, 8 milimetre olarak da tasarlanıyor. Genelde 2,8 milimetreyi aşırma plakalarını istenilen sertlik ya da mekanik mukavemet, aşırma direncine göre, indeksine göre bu şekilde kaplıyorlar özel ürünlerle. İşte tek beslemeli ya da 3 beslemeli aynı anda kaynak yapıp tek poso ya da 2 poso olarak biz bunu farklı Türkiye'deki firmalara da gönderdik, beğendiler. Daha çok aşırma plakası üretiminde kullanılıyor bu ürettiğimiz ürün.
En küçük tel çapı nedir?
1,6. 1,6 milimetre. En çok, en düşük o. En pahalısı o zaten.
En büyüğü
En büyük 2,8. 3,20 de yapılabilir. Tabii o sizin üretim parametreniz, amperinize, voltunuza, sisteminize bağlı.
Teşekkür ederim.
Tek posta 60-60 plaklar veriyoruz zaten. 3 postada dediğiniz gibi tam kendisinden geliyor.
Teşekkür ederim.
Thank you very much for your presentation.
Teşekkür ederim.
Next presenter is Professor Yönetken. Here. We are moving on to next one. Mr. Kaya.
Eyvallah, teşekkür ederim. Size aşar mı diyeyim? Size aşar değil mi? Falan diyorlar. Ya size aşar diyorum.
Mesut Kaya hocam. Mesut Kaya.
Kaya.
Şu an canlı yayında vereceğim zaten.
Bundan mı alalım?
Hayır, bundan bağlanacak.
Peki.
Hocam
Merhabalar.
bana geliyor mu sesim?
Evet, geliyor.
Değerli hocalarım merhaba. Ben Mesut Arta İskender Teknik Üniversitesi'nde öğretim görevlisiyim. Nar kabukları ile ilgili bir çalışma yaptım. Sunumu müsaade ederseniz Türkçe anlatmak istiyorum.
Bilmiyorum. Şöyle beni aradım.
Evet, görebiliyoruz hocam.
Teşekkür ederim hocam. Hocam ben bu çalışmada nar kabuklarını karakterizasyon çalışması yaparak inceledim. Daha sonra nar kabuklarını aktif karbon ve hard karbon ürünlere çevirerek sodyum iyon pillerde e, hard karbonların ve anot malzeme olarak kullanılması, süper kapasitörlerde de aktif karbonların elektrot olarak kullanılması için bir ön kalibrasyon çalışması yapıldı. Bilindiği gibi dünyada atıklar büyük önem arz etmektedir ve bunların birçoğu da e, atık olarak ülkemizde ve dünyada da tarımda gübre olarak hayvanlara besin olarak bulunmaktadır. Ve dünya olarak da değerlendirildiğinde %33 oranında ciddi bir oranda e, tarımsal atıklar vardır. Türkiye'nin e, nar kabuğu, nar bitkisinin üretim miktarına baktığımız zaman da 2022 yılında 647 ton, 2023 yılında da %5 oranda artarak 681 ton olarak gerçekleşmiştir. Ben Hatay bölgesinde yaşadığım için nar kabuklarını değerlendirmek istedim. Hatay bölgesi özellikle Hassa tarafı, Kırıkan tarafı ve Arsus tarafları nar üretimi olarak e, bayağı bir üretimi gerçekleşmektedir. Türkiye sıralamasında da 6. sıradadır. Şekilde görmüş olduğunuz nar kabuklarıdır. Laboratuvar ortamında öncelikle bir kurutma işlemine tabi tutulmuştur. Bu nar kabuğunu Adana Göknur fabrikasından herhangi bir bitkiyle karıştırılmadan e, doğal olarak paketlenmiş olarak tarafıma ulaştı. Daha sonra bunlar 105 santigrat derecede bir gün boyunca kurutuldu ve analizleri yapıldı. Yapılan analizlerin pardon hocam. Bu malzemeler hocam öncelikli analizleri hemiselülöz, selüloz ve lignin yapıları incelendi. Burada özellikle şuna değinmek istiyorum hocam. Yapmış olduğumuz başka bitkisel çalışmalar da oldu. Bu bitkisel çalışmalarda lignin yapısının yüksek olması hard karbon verimliliğinde özellikle sodyum bataryalardaki kapasitans potansiyelinde yüksek olduğunu tespit ettik. Literatür çalışmalarında da buna benzer örneklere rastladık. Nar kabuğunun selüloz, hemiselüloz ve lignin yapılarına baktığımızda da selüloz oranı 12,24 ve lignin yapısı da literatüre göre iyi bir orandadır. Bu başlangıç maddesi olarak nar kabuğunun külü, uçucu madde, nemi incelendiğinde kül oranının düşük olması yine aktif karbon ve hard karbon çalışmalarını büyük önem arz etmektedir. Sabit karbon miktarı da yine istenilen seviyededir. Çalışmalarını bir tüp fırında gerçekleştirdim. MS marka bir tüp fırında yapıldı. Aktif karbon çalışmalarında potasyum hidroksit e, kimyasal ajan olarak ortamda kullanıldı. 1'e 4 oranında, kütle olarak 1'e 4 oranında potasyum hidroksit kullanıldı. Çalışmalarını 800 santigrat derecede, aktif karbon çalışmaları 800 santigrat derecede 10 santigrat bölü dakika ısıtma hızında 800 santigrat dereceye gelen ürün 1 saat boyunca bekletildi ve daha sonra oda koşullarına geldikten sonra tüp fırından aldım. İnert ortam için, inert gaz için de 100 mililitre bölü dakika azot gazı kullandım inert ortam olması için. Hard karbon çalışmalarında da argon gazı kullandım. O da 3 santigrat bölü dakika ısıtma hızında 1300 santigrat derece geldik. 1 saat boyunca bekletildikten sonra yine oda koşullarına sıcaklığımız düştükten sonra ürünümüzü tüp fırından alarak işte demineralizasyon işlemlerine tabi tuttuk. 1 molarlık hidroklorik asitle ve daha sonra saf suyla yıkama ve tekrar 105 santigrat derece kurutma işlemlerine geçiliyor. Sonra kalibrasyon çalışmaları yapılmıştır. Bu aktif karbonun başlangıç maddesi olanlar karbonun ve hard karbonun beta analizi incelendiğinde görüldüğü gibi oldukça düşük oranda bir ham maddenin yüzey alanı görülmektedir. Aktif karbonda kimyasal bir ajan kullandığımız için, potasyum hidroksit kullandığımız için yüzey alanı genişlemiştir. Düzenekli yapılar oluşmuştur. Ve hard karbonda da herhangi bir ortamda potasyum hidroksit gibi kimyasal emperyal kullanılmadığından dolayı yüzey alanı 55 seviyesinde olmuştur. Çalışmamda ayrıca tır analizi yapılmıştır. Tır analizine başlangıç maddesinde ilk baştaki bantlarda karbon, hidrojen ve oksijen patlamaya bu ortamın sulu bir ortam, suyun nemin olduğunu göstermektedir. Daha sonraki işlemlerde, analizlerde de özellikle hard karbonda XRD ve Raman analizleriyle karşılaştırdığında grafikleşme oranının arttığını, karbon-karbon zincirlerinin olduğunu görmüş. Çalışmamda ayrıca SEM analizleriyle yüzey morfolojik yapıları incelenmiştir. A'da nar kabuğunun yüzey alanı, B'de nar kabuğundan elde edilen aktif karbonun yüzey alanı, C'de ise hard karbonun yüzey alanı, yüzey gözenek yapısı görülmektedir. Burada B incelendiğinde gözenekli yapılar görülmektedir. Bu da dediğim gibi potasyum hidroksitin ortamda kimyasal tepkime sonucu delikli gözenekli yapılar oluşturmasıdır. B ve A ve C'ye baktığımız zaman şekilde orada da kaba, düzensiz yapılar mevcuttur. Son olarak çalışmanın şunu söyleyebilirim. Potasyum hidroksit kullanılarak aktif karbonun yüzey alanı 692 metrekare bölü gram seviyesine gelmiştir. Hard karbonda herhangi bir kimyasal ajanı kullanmamasından dolayı yüzey alanımız 55 metrekare bölü gram seviyesindedir. Yapılan bu çalışmalara baktığımız zaman aktif karbonların süper kapasitörlerde elektrot olarak kullanabileceğini, elde edilen hard karbonun ise sodyum bataryalarda anot malzeme olarak kullanılabileceğini söyleyebiliriz. Beni dinlediğiniz için Sayın Hocama çok teşekkür ederim.
Thank you very much for your presentation. Is there any questions regarding this paper? Teşekkür ederiz hocam sorunuz için.
Sağ olun Sayın.
Kendinize selamlar. Okay. Our next presenter is Ms. Gürsoy. Paper titled Removal of Boron and Boron Compounds from Wastewaters. See here. Burada mı hocam?
Çevirmiş olabilir mi?
Sayın Hocam, sorunuz var mı?
Hocam sorumuz yok. Teşekkür ediyoruz.
Ben teşekkür ederim Sayın Hocalarım. Ekranı durdurayım mı Sayın Hocam?
Yapabilirsiniz hocam. Çıkış yapabilirsiniz. Tamam. Sayın Tören Özgün burada mı? Tören Özgün. Sayın Kaya Alp. Sayın Yönetken.
Merhabalar.
Merhabalar.
Ultrasonic spot welding konusu benimdi de Sayın Ahmet Yönetken hocamızın adını yazmıştık. Sunumu ben yapacağım.
Evet hocam, takdim edeyim size. İsminiz nedir?
Güldenur.
Güldenur hocam. Hoş geldiniz.
Hoş bulduk. Ben ekran paylaşabilirim.
Ms. Güldenur is presenting a paper titled Investigation of the Weldability of Glass Fiber Reinforced Polyamide 6 Composite Materials in Ultrasonic Spot Welding Method. Ms. Güldenur, you have 15 minutes.
One minute. Bir dakika. Ben ekran paylaşmaya çalışıyorum şu an ama
Siz Zoom'dan bağlanıyor. Siz açmayı isterseniz sunu.
evet, ben sunumu açamıyorum şu an. Telefondan bağlandım ama ben ekranı paylaşamıyorum.
Ekran paylaşma çıkmıyor mu hocam?
Paylaş dediğimde sunumumu göremiyorum. Şu an tekrardan bakıyorum.
Burada yüklü mü sunum reji?
Seçilmiyor hiçbiri. Hata veriyor.
Size göndermiş miydiniz hocam sunumunuzu?
Sanırım göndermedim.
Size gönderebilirseniz biz buradan açabiliriz isterseniz.
Önce bir ekranı gör.
Tamam, hızlıca gönderiyorum. Ahmet Hoca adına mı göndereyim yoksa mail adresiniz var mı?
Hangi mail adresine göndersinler? Bana hangi mail adresi açıp? Hocam icmatse@gmail.com'a gönderebilirsiniz.
Tamam, hemen gönderiyorum. icmatse@gmail.com. Gönderdim. 1-2 dakikaya gelir sanırım.
Evet geldi hocam. Şimdi şu arkadaşlarımız.
Süper. Aynen o.
cevap sunumunuzu?
Evet, görebiliyorum.
Tamam. Süreniz 15 dakika. Buyurun.
Teşekkürler. Hi again, I'm Güldanur, and my topic investigation of the weldability of glass fiber reinforced polyamide 6 composite materials in ultrasonic spot welding method. And other page, thank you. This study investigates the impact of ultrasonic spot welding on the bonding of engineering plastics. Polyamide 6, a commonly used engineering plastic, was reinforced with two different ratings of glass fiber, 15% and 30% GF. Three polymer materials for polyamide 6 and the glass fiber reinforced variants were prepared as lab shear tensile test specimens. Next space, thank you. The materials were welded using ultrasonic techniques under three different parameters: pressure, welding distance, and amplitude. And their weldability was assessed. The Takuchi method and ANKARA analysis were employed to identify these optimal parameters. And mechanical tests, including tensile and hardness tests, were performed on the supplies. Next page. The ultrasonic welding method has numerous applications in various industrial fields, including automotive, aerospace, medical, electronics, electrical application, and many others. They have done a lot of work on ultrasonic welding in 2020 study and Zenko in 2022 study. Next page. Materials in this study: unreinforced 0% glass fiber reinforced and 15% glass fiber reinforced and 30% glass fiber reinforced polyamide 6 materials were used. Next page. Takuchi method was used in this study. The orthogonal array used in this study is the L9. Then the variance method ANOVA linear model was used for the statistical analysis of the experimental result. Then next page. Then methods for the welding application: tensile test specimens were molded according to ISO 527 standard. A total of 10 specimens were molded from each of the shape test bars, and mechanical tests were performed. Next page. Then ultrasonic spot. In this study, three different pressure: 30, 40, 50 bar, and three different amplitudes: 80%, 90%, and 100%, and three different welding distance were used as welding parameters. The welding distance were 4.5 millimeter and 5.2 millimeter and 5.9 millimeter. Then a blind hole was applied, meaning that the hole does not penetrate to the other side. The joining area was welded in the circular shape. The welding process with a blind hole from the photograph of the specimen that broke after tensile test are shown in the feature. results with ANOVA analysis for the polyamide 6 plus 0% GF, the parameters that most affect the tensile strength and percent elongation results are in order pressure 50 bar, welding distance 5.2 millimeter and amplitude 100%. Next page. Then for polyamide 6 plus 15% GF, the parameters that most affect the tensile stretch and percent elongation results are in order pressure 40 bar, amplitude 100% and welding distance 5.2 millimeter. Then in case of the polyamide 6 plus 30% GF, the parameters and most affect the tensile stretch and percent elongation results are in order pressure 13 bar and amplitude 100% and welding distance 5.9 millimeter. Then in the hardness measurements taken from the samples, it was observed that the hardness values in the weld region were higher than just in the base material, and an increase in hardness was not as a glass fiber contact increases. Conclusions. The following conclusions from the experimental study conducted using ultrasonic spot welding. One, a reverse correlation was found between the glass fiber content and the pressure parameter. As the glass fiber content increases, reducing the pressure results in higher shear force for optimal outcomes. Then, as the glass fiber content increases, ductility decreases and the material becomes more brittle. Then it was found that hardness increases in the weld region and decreases as the distance from the weld region increases. Last conclusions, the ultrasonic spot welding method should be preferred, particularly in application where aesthetics are less critical. My references. Next page. Thank you for listening.
Thank you very much, dear professor. Is there any questions regarding this presentation? Thank you very much. Hocam çok teşekkür ederim.
Ben teşekkür ederim. Kusura bakmayın. İlk denememde biraz heyecanlandım. Kolay gelsin size.
İyi akşamlar, sağ olun.
İyi akşamlar.
Okay, our next presenter is Ms. Gürsoy. Is she here? Mr. Kayal. Ms. Tören Özgül. Son konuşmacılar gelmemiş sanıyorum. Var mı Gülsoy hocam? Var mı? Hocam, hatta mısınız?
Yok arıyoruz hocam. Gelecek size.
Pekala.
Kendisi yok.
Bir 5 dakika bekleyelim. İsterseniz bu süreçte ihtiyaçlarınızı giderebilirsiniz.
Tamam. Öyle çekildi. Git. Git tamam. Git. Bak. Git. Rahat ol. Bak. Ben dediğim konuda tutamıyorum. Buna hiç gerek yok diyorum ben. Ama ben de aynısını bekliyorum. Çekerken böyle iyi.
Herkes
Ben varım.
ama konuşmacı olduğumuzu bulamıyoruz.
Bunlar yok mu? Hakan hocamıza bir soru kafalar.
Abi biraz eğilerek çeker misin yine ya? Bir saniye. Aa, bu ne canım işte olmuş. Yeri var bir tane. Alta yerden. Ne çıktı oğlum? Aynı çekiyorsun. Ne aynı çıktı? Ben çekiyorum ya. Bak. Bak. Böyle parçalıyorum. Böyle değil. Şöyle bak. Biraz iyi plan. Tamam bir kere daha. Şimdi bayağı kapatacağız. Bunda eğitim kayıp dayalı. Gerçekten aklını koymamayacak. Abi. Geç be artık. Geç.
Yok ben hiç bilmiyorum.
Tamam. Fotoğraf yüksekte kalmıyor, tamam mı? Geri çek. Belli oluyor. Bir dakika sonra geliyor. Aşağı. Aynı zaten burada. Gel. Bak.
Ben çalıştım. Ama ortadaki
Ondan dolayı değil. Arkadaşlar. Bak şimdi ben senin göz buradan da görüyorum. Alttan da görüyorum. Kadrajımdan. Oturuyorum. Bak benim
Hayır bak şimdi onu söyleyecektim. Kare var ya, kare yüzüme gelsin. Yarın bastığın zaman yeşil olacak. Yeşili alacaksın ondan sonra çekeceksin. Bak yukarıda joystick var ya, joystickle şey yapabilirsin. Hafiften netleştir. İleride USB ne oldu? USB ne oldu? Ayar mı oldu? Sonra seni çekeceğim ha.
Bence oluyor. Ama aşağıda çıkıyor.
Aynı şuradan bir kameramla beraber çeker misin? Gayet iyi.
Şu olmadı.
Şey gibi oldu. Hadi bir kameramla beraber çeker misin?
Peki. Çok profesyonel geldi. Artık olmadı. 150.
Evet, oradan da alayım lütfen. Sıkı tut, tamam mı? Karşı olma.
Evet,
Hayır,
şöyle
ben-
bilgi verebilirsiniz arkadaşlar.
Tamam, bir çalışıyor. Nereden alacağım bu fotoğrafları?
Aslında gayet bir
Our next presenter is İpek Gürsoy with her presentation titled Removal of Boron and Boron Compounds from Wastewaters. Ms. Gürsoy, you have 15 minutes.
Ses için biraz mikrofona yaklaşmasını istiyorum.
Sunum farklı sanıyorum. Sunuyu düzeltebilir miyiz?
Bunu fark
Flash içerisinde ICMATSE sunum olarak geçen bir sunumu açınız. Hocam biraz mikrofona konuşmanızı rica edeceğim.
Hocam eğer diğer mikrofonu verebiliriz elime. Şuna ver. İlk madem şeklinde genelde bir kod ayakta daha yapacak.
Buradan bakabilirsiniz. Orada yıkanıyor. Bu olabilir mi hocam?
Ekranda görüntü. Sorun değil. Sorun değil.
Hocam yani gidelim.
About removal of Poland even if myself my name is here this ama işte bu da ayarlamadan hocam ben ayarlıyorum. Mikrofonu çıkalım ben ayarlıyorum herhalde. Ben buradan kontrol edeceğim.
Siz oradan sunuma karışmayın arkadaşlar.
Hocam orada sunum aleti var. Onunla geldi.
Ben zaten kendi oyunlarımı yazmıştım. İlerleyeceğim.
Onun aparatı takılması var.
Yani nerede ucunda
Hocam, zamanımız geniş vardı. Aslında yapabilirsiniz. Bir sorun varsa yine düzeltirim. Oradan geçiş yapmak istiyorsanız yapabilirsiniz.
Tamam, ben kendim geçeceğim.
Tamam, teşekkür ederim. Evet.
Daha sonra olayı güveneceğim. Kullanmamızda bir seçimde bağımlılığının doktoransının kullanması teorisi olur. Let me first introduce myself. My name is Victor, so PhD University of Gazi University in The content is consists of the aim of study world, the relevant methods, the program discussions, conclusions, and references. Let's first talk about the aim of study. Boron is an essential micronutrient for plants and animals. However, when it is taken in high dosages, it can be harmful and poisonous effects for living. Also, wet waters having high boron content can cause problems if precautions are not taken. So, it was aimed to remove boron from wet waters of mine works using modified and natural absorbents in the study. General information about boron. Boron, shown in three group in the periodic table and shown with this symbol, has semi-metallic and semi-conductor properties. The most important property of boron is that it's very hard and resistant to high temperature. And it is never formed freely in nature. It tends to bond with oxygen. And these minerals are called as boron salts. And the oxygen-boron compounds are called as borates. In Turkey, the industrially important boron compounds are borax, the other name is silicate, that's sodium-based boron compound, flamonite, that's calcium-based boron compound, and next is sodium-calcium-based boron compound. Boron is used in many areas of life, for example, mostly in glass, in agriculture, in wood, in health, and also as flavor retardant in many areas of life. The impact of boron on environment is to air, to soil, and to water. On water, effect is on drinking waters and on agricultural waters. Wastewater generated during the mining operations can cause problems and reach high values if precautions are not taken. So, and also they can be harmful for aquatic creatures and plants if they use in agricultural irrigation. And then they can be harmful to people who use them in their diet. There is legislation in Turkey for limit discharge values for boron, and these values vary depending on the environment where the wastewater will be charged. For example, for desalted seawater, that's 500 ppm, according to the water pollution control regulations. And for example, the other one, the maximum boron concentration allowed in drinking water is 1 milligram per liter ppm, according to the regulation on water for human consumption. There is no simple method for boron removal from water that was used. So, around the world, in ongoing projects, still, an economic method is sought for. Say, adsorption can be a good candidate for this because of its easy application. But making adsorption with non-adsorbents makes the process expensive. So many researchers have directed their studies to abandon and cheap adsorbents. These are environmentally friendly natural vessels. And it is important to evaluate them from environmental and economic perspective. Also, these adsorbents can be reused by regeneration. Let's look into the materials and methods. In the first part of this study, wet waters were taken from its mine works and made boron gas factor. Lab water has a high boron value as 5,883 ppm. For absorption studies, different adsorbents as west class that were obtained from MS, Bandırma, Bigadiç, and Kırka operations directorate and Light was obtained the area site of its mine Bigadiç operations directorate. Most were used modified walnut shells, modified waste compost, and modified wet sunflowers stems as adsorbed in different studies. Absorption studies were carried out in shaping thermostat water baths and different parameters such as amount of adsorbents, pH value, and particle size were used to see the effect of these parameters on absorption. And the absorption processes, unfortunately, found insufficient and ineffective for the voltage because voltage have very broad content. For this reason, it was thought that it would be more appropriate to remove some of boron vessels by chemical precipitation using lime than to continue with absorption process using molecular modified absorbers. In the second part of study, the boron removal from S-phase spring water, which is located in Emek S-phase open pit site, was studied because it has also a high amount of water, such as 4,000 values, in the framework for social responsibility, because this water mixed with projectile ceramic stream, and that water is used for irrigation and irrigation in different areas such as Susur Basin. So the high amount of water in this water can cause problems. So we decided to work for removal of boron from this water. First of all, chemical precipitation took place in a temperature-controlled magnetic stir heater line. Afterwards, after absorption process was carried out, different wet absorbents such as modified Mornat shells or the modified almond shells and lastly modified sodas were used. Absorption studies were carried out as in the first part of the study. And as in the first part of the study, different parameters such as pH, amount of absorbent, and also particle size were studied to study the effect of thermal absorption. And also, actually, also with sawdust dilution ratios were studied to see the effect of the dilution ratio on absorption, also as well as with not diluted pure S-phase rainwater. Let's look at the results and discussions. For wet colloids, 2 grams of wet samples were put into 100 milliliters of boron wet sulfate. There's not wet water, that's spring water. Sorry, first part I say. Wet water at 25 centimeters for 2 hours in 100 RPM for fast shaking water bath. According to the filtration method, the results we will look at table 4.1. During the whole study, also boron values were determined according to filtration method. And from the table set, inefficient results were obtained, considering the initial value was nearly 5,000 ppm values, and also there was an increase in the amount of boron output values compared to the initial value. This was due to the release of boron during absorption from clay minerals that are extracted from the same mine and saturated with boron. And the study continued with zeolites. Zeolites were fractionated and indexed at 1 to 2 respectively, according to table we will see. They were subject to the absorption for 1 hour, 1 hour and 45 minutes, and 2 hours. Absorption studies were carried out as in the previous study. 2 grams of zeolites were used. According to this result, we see that particle size and time didn't have efficient results on absorption for removal of boron from wet water. And as a result, we understand that this is the result of the boron-rich zeolite found in the same area with boron in boron local soils. So it was thought that it didn't have sufficient capacity. So a new absorbent walnut shell metal was present with flood. They were broken, these particles ground deep in a vibrating C1, separated into fractions. Two different acids, hydrochloric acid and sulfuric acid, were used to modify these particles. And all shells with plus 500 micron fractions were used. After modification, they were washed with pure water filters and heated in an oven. The reason for choosing this particle size was to report the absorption with other smaller size particles if successful removal was achieved with the particle size. 2 grams of walnut shells were chosen. The aim was to understand the modification with acid will give good results or not, and also to understand which acid treatment will give better results for absorption. And as we see from the table for factors, both acids gave unfortunately inefficient results. Studies contact with pH at that point to see the effect of pH on absorption. Different pH values such as 2, 7, 9, and 11 were studied. The pH of initial boron vessel was 4. 2 grams of brown shells were used. And according to this result, as we see from the table, that as pH value increased, the output value decreased. However, precipitation, which is the mass, also increased. So optimum pH for removal was supposed to be as 9. Of course, in order to understand the amount of absorption, 2 grams and 4 grams samples will be studied. And according to this table, we see that slightly amount of absorption as amount of absorbance increase, slightly efficiency increase. This was due to as absorbent amount increased, number of absorption sites increased on the absorbent surface as well. Due to the inefficient result, less form salt and less sunflower stems were decided to be used as absorbents. They were treated with also hydrochloric acid and codeine hydroxide. 2 grams of samples were used in the studies, and in the same conditions, we say the same conditions, the same temperature, 25 degrees and 170 RPM heating rapids. Because if we had a successful result, we thought also to study these parameters, but unfortunately, we didn't have. So when we look at these results, the inefficiency results again output values. So the study turned to the S-based spring water, as I said before, in the scope of social responsibility, and that was also high boron content as for 1,590 ppm. First of all, chemical precipitation took place in a temperature-controlled magnetic heater at 25 degrees centigrade at a rotation speed of 760 RPM. 1 hour working time, 1 hour waiting time was selected. And we see the results. As lime amount increased, the output value of boron decreased. However, the amount of sludge also in the work was produced as a result of chemical precipitation, which we don't want because of the environment project. So 5 grams of absorbent ought to be sufficient for purification. So when we look at the results, they decreased from 4,590 ppm to 424 ppm, very good result in terms of purification, in terms of chemical purification. Then absorption process took place. For absorption, walnut shells in 500 micron fractions with hydrochloric 0.1 hydrochloric acid treated with this acid were used. 4 grams and 2 grams were studied. And we see the results as amount increase, as I explained before, slightly efficiency obtained. And however, with this result, it could be considered that the boron removal was not sufficient. Because of this, it was decided to continue the studies by adjusting pH. According to formal studies carried out with walnut shells and scope, this study pH was adjusted to 9. 2 grams and 4 grams of walnut shells were used. Same conditions were applied. The results are shown in table. As again, amount of absorption increased, the amount of absorption increased slightly. Compared to the former study without pH adjustments, the amount of boron removal from vessels increased by adjusting pH to 9. In summary, the absorption studies carried out with hydrochloric acid activated walnut shells of 500 micron particle size, as the amount of absorbent increased, a very small decrease was observed. Again, in the study conducted by adjusting pH of S-based spring water to 9, more efficient results were obtained compared to the study with pH of 11.67 original pH. The highest yield was obtained 4 grams of absorbent at pH 9 with 379 ppm. In order to understand the effects of particle size on absorption, the main walnut shells were ground and sealed. The walnut shells with minus 63 micron fraction were studied for absorption studies. As a result of study conducted with 2 grams and 4 grams of walnut shells in the 500 micron fraction, it was concluded that this two different amounts of significant effective oil and spring water. Also, amount of substance we have no 2 grams of alcohol while talking studies were carried out with minus 63 microfractions. Afterwards, different pH values were studied. The pH values studied were 11.30, which is the pH of both acid-treated walnut shell addition, and after pH adjustments as 12, 9, 7, and 4. We see the tables. We see from the table that according to these results, with an output value of 346 ppm, the optimum removed pH could be considered as 9. Let's explain the reason of this. It could be thought that as the degree of acidity or alkalinity increases, in this process, absorption negatively affected because the walnut shells, which modified hydrochloric acid, has positive charge. So in this situation, an absorbent expected to be negative charge. As pH is an important parameter affecting the behavior of boron in a solution. In pH values below 7, boron behaves as boric acid, non-ionized form boric acid, and pH values greater than 10.5, it behaves as negatively charged borate. So in this condition, borate is more favorable for positive charge surface. At high pH as 11.30 and 11, the reason for decrease of boron absorption is that hydroxyl ion competes with negative charge ion on the surface of alcohol. So at higher pH, positive charge surface turns to negative charge. It was observed that when particle size decreased, the absorption efficiency increased slightly, because as the particle size decreased, the surface area of absorbent increased, and resistance to reach the pores will be shorter and easier for diffusion occur. In order to use a different environment absorbent, the use of almond shell was considered in order to be similar to the walnut shell study. Plus 5 micron fraction and minus 63 micron fraction were thought to be used in absorption studies. Almond shells with 500 micron fractions were used. Different pH values were studied to the effect of pH change on absorption. The pH values studied were 12 on pH after addition of almond shells to the water, 9, 7, and 4. 2 grams and 4 grams were used absorption. The same conditions, that means that the temperature in the same shaking rapids was carried out. We see the results from the table set for both amounts. The optimum pH value was found to be 9, as I explained before, because of the pH factor, because the effect of pH on the surface and behavior of boron, and as the amount of absorbance increased, the output values decreased. Then the absorption process was carried out with almond shells in 63 microfractions. Since we didn't have enough material for this fraction, the study was carried out with only 2 grams. Again, pH factor was studied, 11, after addition of almond shells to the water. Then after adjustment, other pH is 9, 7, and 4, the same for this water. Wait. We can say that as the particle size, and also we have talked before, particle size decrease, surface area of increase, reach to pores will be shorter and easier for diffusion of fluid. We see the photographs for almond shells absorption, filtration, or concentration, after filtration and in absorption water, that's shaking water. Then another environment-friendly waste material, sawdust, was studied. Sawdust was treated with sodium hydroxide. 2 grams and 4 grams were studied. Because if good result, we thought to make larger, for example, different amounts, different temperatures, different shaking rates, but that was only the basic ones. Also, absorption studies with sawdust were carried out by different dilating ratios, such as 1.5, 1/5, and 1/10 ratios, with also not diluted pure and basic water. We see the results for different dilution rates. The best results were obtained with 1/5 dilution rate, with going 17 ppm, that's approximately 26% for removal. From a natural algorithms, we thought that is the efficient boron removal. Because so that's the material where the forest cell was extracted and complexation with hydroxylate carboxylic and found groups in structure of soda occurred. In addition, it could be mentioned that the treatment with sodium hydroxide has a positive contribution to absorption in terms of removing impurities in the absorbent and allowing easier access of boron to the pores. As explained in literature, as well as the pH value, concentration also is an important parameter which affects the behavior of boron. At lower concentrations as 270 ppm boron behaves as boric acid and boron ions in the environment. However, at higher concentrations than this value, conversion to polyborates occur. The reason for positive effect of dilutional absorption also was that as a result of dilution, boric acid and boron ions present in water at low concentrations. And this could be excited easier absorption occurs after dilution compared to glass molecules such as polyborate, which was thought before dilution. These results show that boron removal increased with dilution absorption method, but after a certain dilution rate, that was 1/5 ratio for the study, boron removal started to decrease again. In short, it was observed that there was an optimal dilution rate for boron removal. Based on these results, as well as the boron behavior, it could be also concluded that the active area of azote might be insufficient at high boron concentrations. In other words, since all active areas were occupied by boron, the absorption phenomenon reached dynamic balance, and the amount of azote was increased and the absorption size was carried out with different dilution rates. It was decided to repeat absorption studies for different dilution rates by increasing the amount of azote. Also, other natural absorbers in my study, for example, activated carbon, which is produced from waste products, will also be used. For my study didn't finish yet. I will also look at the if we find a good. We thought that if we find a good absorbance, for example, we found at the anti-solvents and almond shells, we will try the effect of other parameters and to see which isotherms, which our experimental results fit to the which isotherm is better from the Landwehr or another one. And also thermodynamic values will be delta G deltas will be obtained, sought to be obtained, and also kinetic values of absorption will be also studied. That's only just one part of our study for this conference. It hasn't finished yet. Only part that I studied, I tried to present you. Let's look at the conclusions very shortly. Among the other environmentally friendly outdoor nature outdoor we studied, so that almond shells showed effective performance in our social studies. So that there was a optimum dilution rate for removal of specific ring water. As for conclusion in literature, there are lots of studies which are carried out with synthetically prepared boron solutions. However, in our study, we will study real west waters and also specific rainwater in the frame of social responsibility. That makes our study specific, and also that's important that from environment and economic perspective, boron from waters which have boron content with evaluating natural west absorbance. This makes this study with absorption methods specific. Our study will continue just on one part of it, just on that part of it. Thank you very much for your listening and coming. Thank you.
Thank you very much. Is there any questions? Please go.
Fazla su içseniz bile zehir olur. Bizim ülkemizde %70 rezervi olduğunda ve çevreyle ilgili çalışma yapan arkadaşlarımın bu konuda daha hassas olmasını arzu ederim. Yani bor zehir yani ne içerseniz fazla ise zehir. Bunu öyle algılamak lazım. Türkiye'de %70 boz rezervi var. Bunun %70'i zaten emek. Yani oradaki zaten doğal. Kaldı ki bunun prostat kanseri ve diğer şeyler için essential bir element olmasa da vücutta e, bazı tedaviler için kullanılıyor. Ve bunun bir zararı da yok. O limit değeri dördüncü referansınızı vermişsiniz. Dördüncü referans limit değeri ama kime göre? Aslında güzel bir çalışma olur yani. Bu bir limit değerini biz kendimiz yaptık. De karşı bir silah olarak kullanılıyor. Ne? Çamaşır deterjanı ve şey ürettiğimiz için bizim Avrupa'da ve diğer sistemde bunu takmamamız için bir de ne yapıyorlar? Bir engel olarak teşkil ediyor. O konu benim için çok hassas. Evet. Hı hı.
Yani
Yani o zaman daha dikkatli olmamız lazım. Çünkü bunu bize silah olarak kullanıyorlar. Yani o değer işte 500 ppm dediniz, öbürü 5000 ppm. O zaman buradakiler öyle kaldı. Dünyanın öyle noktaları var ki radyasyon olarak 80-100 milisievert, yani bir radyasyon çalışanı bir yılda alacağı dozu 20 milisievert olarak kabul edersek onun 5 katı olan yerler var. İnsanlar bu radyasyonda yaşıyor. Orada baktığımızda bunun yanında çok zehir tabir etmeyeceğimiz şekilde bir ürün olarak takip etmemiz gerekir. Hele hele çevreci olarak sizin buna daha iyi odaklanacağınızı düşünüyorum. Çok teşekkür ediyorum.
Yani özellikle bu Avrupa'nın Amerika'da da zaten bu kuraklık var. Yani özellikle çıkarılan işte bunun faydası olabilir. O kadar benim az önce sizin anlatmaya çalıştığım yaşam alanında sağlık sektöründe biz yani mikrop öldürücü olarak yani yaşam özellikle son zamanlarda bu faydası savunma sanayinde özellikle senin için önemli olan yani alev geciktirici, yangına karşı kimyasal sanayinde yani birçok belki aşırı hayatta dediğimiz bu her şey zararlı. Zararların sonra faydası o kadar yok ki ekonomik gidebilir. 500 milyon diyoruz. Dışarı gelip ama zaten yenildiği zaman doğayla mesela işte yenileri atıldığı zaman bir şey çalışan verilecek. Yani yine büyük yanlışlar olayların yanında işte Karadağ'da oluştuğu devletlerin sebepleri bunları yapıp bunun zaten denizde tarihi kadar diyebiliriz. Teşekkür ederim. Ama o çalışma konusunda sağlık önemli. Yani neden bu mevzuatı tekrar yeni yapmalı? Yani bir ya da bir mevzuatı yüksek yetişmesinde 0.5 olmuyor ya da bir yani 100 olmuyor. Yeni baştan bir düzenlemede düşünülebilir. Teşekkür ederim.
Any other questions?
Çalışalım. Yani biz hocam sanat hocamız soruldu. Doğrusuların arasını atlattığı bir çalışacak ve çok tek oraya sahip gördüm. Geçmişlerde yani şeyde bilimde yaptığım için ben doktora çalışmasını bu aslında değerlendirmesini fakat ne yazık ki yani her şeyi anlattığım kadarıyla bulamadık ki biz güzel alternatör bulduğumuz zaman bunda sıcaklık faktörü şartlamamızda yani birçok örnekte yapalım, bizim kendileri çıkaralım, termodinamik, biyotik parametreyle parametreyle çıkaralım. Çalışmamızda bizim bir akıldan kullanmıştık fakat bunu da savaş ile anlaşmalarla bunu ifade ettik.
Çamın talaşı, yani çam, onun bir sürü onun çeşidi var ama çamı kullanırsanız daha iyi olacağını düşünüyorum.
Son ilk hocamızın şöyle bir örnek de var. Yani aktif karbonu, zaten de aktif karbonlardan da arasını yapabilir. Yani burada hazırlanmış zaten bir şey var. Bu küçük konsantrasyonları. Kolaylıkla bir şey bizim çok yüksek. Bu senin var. Bir tane
Aktif karbon elde edebilirsiniz. Onu da kullanabilirsiniz. Yani o reçine bir e, talaş olacaktır şeyinki. Onun arasında e, karbon, aktif karbon olarak multilayer yapabilirsiniz. Yani.
daha güzel neticelerle başka bir konferansta ile Ne paylaşmak istedim.
Çünkü su arıtma sadece buradan değil, başka şeylerden de belki yarın başka bir arıtma ihtiyacımız olabilir. Tabii.
Çok teşekkür ediyorum. Sağ olun.
Thank you very much, Mr. Gürsay.
You're welcome. Buyurun.
Our next presenter is Pelin Tören Özgün. With her paper titled Recent Advances in Polymer Materials Used for Biomedical Applications. Please welcome Pelin. Pelin. Okay, okay. So we're going to have a few minutes of break. All right, we are back. I'm inviting Ms. Pelin Tören Özgün with her paper named Recent Advances in Polymer Materials Used for Biomedical Applications. Ms. Özgün, you have 15 minutes.
So, good afternoon. My talk is about recent advances in polymer materials in the biomedical field. So,
I'm currently a faculty member of Materials Engineering Department in Boston Technical University. And before that, I think this pointer is working. No? One of them must be.
Hocam sunum aleti var orada.
So, would you please guide me which
Onun bir tanesi çalışıyor.
Okay. So before Boston Technical University, I served 6 years Austrian company, and which is doing research with 7 departments. I was in the material section of that company, where we established some pilot line for polymer components that are used in biomedical devices. And these pilot lines were supported by some European Union project. So I told this about the pilot lines, these roll-to-roll based pilot lines. I'm going to show you some examples that we produce for different companies. And then I'm going to mention this 4D printing, which is a hot topic now for biomedical field, the smart shape memory polymers. And I'm going to say a few words regarding conductive polymers that are used in biomedical field as well. But again, I talk in this way. Okay. So, okay, this is working when I start below. So here, from nano to macro, printing opportunities again, where we can use this roll-to-roll polymer printing is that sensor chemistry, functional printing, optics, or you can create some components that I'll show to you. Okay. That one pointer. Okay. So here, the roll
If you like, they could switch pages from the
okay, thank you. That's further. Okay, thank you. So here, as the color leaves traces on the snow, when you imprint in a roll-to-roll section, you can imprint microstructures as well, like microfluidic channels, okay? So roll-to-roll is handy because in terms of high throughput, you have plenty of options. Sophisticated structures can be printed. And in a minute, thousands of structures on a single polymer foil you can print. Next slide, please. Thanks. So here we see the scheme of this roll-to-roll, this pilot line located in Learning Research Company. So here we have a foil that is covered with kind of uncured resin, okay? And this resin goes into this middle section here. Here they're located the middle section where is the heart of this pilot line. The stamping occurs under the uncured resin there. And behind that, since the polymer foils are transparent, we hit the UV light. Why the UV light it gets cured? So therefore, with this way, on the flexible foils, you can have very sophisticated structures. Next, please. And then this pilot line with a continuing project, with the next generation project, linked with together with another pilot line that performs DNA or protein, in terms of antibody printing with some piezo nozzles. So in a single line, you imprint certain structures on polymer foil. Then you can print your, for instance, single-stranded DNAs, okay? And then we cut the chips and we convert it into single chips at the end. So there is a company called JetSpeed in Amsterdam. JetSpeed integrated these chips to their medical devices. So in pandemic, we learned this in certain times, disposable chips for testing purposes of patients
and the supply of these disposable chips in thousands each day is crucial. So high throughput technologies and the existing innovations in the polymer science pushing the limits. Okay, so next slide, please. Thank you. So where we can use these microfluidics to structure these polymer chips? You see here some imprinted structures for different medical purposes, but here they're located the microfluidic channels, which can be used in these medical devices for DNA testing. For example, the device is commercially available for MRSA testing. MRSA is a very stubborn pathogen, as you know, in the hospitals, a big problem. So it can, with different strands, simultaneously, in a multiple manner, it can test the different genomic material. And apart from that, or in addition to that cell cultures, neuron studies, for them also disposable medical components are required. So with this roll-to-roll technology, you can imprint. Next, please. That's the second continuum pilot line that I just mentioned. This makes this protein or DNA printing, okay? So here goes the foil. It's been imprinted to structure to the section 3, where located some nozzles. And these nozzles drop volume is around 50 to 800 picoliters. They release the biological components that you would like to attach onto the surface, into the microfluidic channel, for example, and they really adhere. You don't have to do any further or detailed, complex functionalization indeed. So polymers are handy in terms of cost reduction, in terms of flexibility, and in terms of functionalization. So we see here the piezo dispense capillary is releasing in certain spots, like 8 to 200 micrometer spot size. Okay, they are releasing. So microarray spotting is possible. With the fluorotect single-stranded DNAs are spotted here some years ago, and you see the spots under the fluorescent microscope. Next, please. Okay, here how it works once again, the roll-to-roll. Number one, you have this imprinting for your sensor structure, for your marker channels, for instance, and of course the uncured resin gets cured by getting exposed to what? To UV light. And then the structured foil is brought in contact with what? Microspotting unit. Next, please. Here the finalized biochip we see here. And GenSpeed company replaced this chip with the chips that were produced by this European Union project. That was here. We see the DNA sequence here. Okay, and this work was published in Lemon Chip. It was a cover. It attracted attention. So if you would like to feel like getting more details, you can go through this paper of us. And the illustrated chips also lies in here. The 3 layers, completely laminated, completely polymer layers. Next, please. The details of these layers, okay, you have bottom part, you have structured part, and a cover part. Here are the inlet opening. In an automated way, I mean, the device, medical device can be automated, but it releases the sample through this inlet here, okay? And the fluid flows by capillary action inside the microfluidic channel. Next, please. The result, of course, here we tested how the device is working, that the enzyme reaction occurring, and then some fluorescent light we obtained, and we checked each arising signal from the strands. We proved that multiplex DNA testing inside the chip using that medical device was possible. And here some more optical microstructures I would like to show. to non-liquidic channels, as I said, sophisticated different structures are possible. Next, please. Whereas these cell culture, cell well analysis can be replaced by polymer foils, high throughput production. As you see, the foil imprinted, and each well has certain microfluidic channels with different directions that is used for selective cell growth in a particular study. And what we see here are the neuron cells. The neuron cells kind of like the surface, and they elongated their arms through each other, which was a very good result indeed. Next, please. The next slide, please. Next slide.
Sunumla ilgili arkadaş.
Okay, thank you. So, of course, all these were coordinated by that company in Austria, and then they had a continuing project. I worked a bit for this testbed upscaling project as well. And then I returned back home. And here, the options are, variety options, structuring options are possible. You can click on this lecture microfluidics link to gain more information if you want. Next slide, please. Okay, next slide, please. Now I would like to also shortly mention the 4D printing, which nowadays I'm quite interested in. The FDM printing, fused deposition modeling, is a hot topic now, in my humble opinion. The 3D printing, conventional 3D printing, is kind of replaced by FDM. What FDM has, so this is an additive manufacturing technique, but it has a great raw material section where the raw material gets melted, passes through an extruder, and then enters to the 3D printer, as we know. So instead of filaments, you create your own filament before it. And here, if you functionalize in a way that is print that it has a shape memory, that's the 4D printing. Okay, next slide, please. I want to study here. They have this FDM printer here, the granules, pass through the extruder, and they printed some scaffolds for tissue engineering purposes. It prints scaffolds. The polymer scaffold is then functionalized by graphene oxide particles when they gain shape memory feature. So near infrared light stimulant polymer material, this is now NIR triggered this material and the phase transition occurred. That was interesting. So this is one of the recent hot topics. Next slide, please. This is also interesting. Here you can find the reference that polymer that shape as it is tuned between certain temperatures. So we see here a finger-like structure. Soft robotics is getting really a lot of attention now because it has very interesting application fields like surgeries, in diagnosis, in drug delivery, drug release purposes they are used, and in the medical devices, artificial organs can be produced by using this shape memory soft polymers here. Next, please. Also, one of the other recent advances in this field in conductive polymers, like P dot or PSS, or mixture of P dot PSS polymers, we can create some different sorts of conductive layers where they can be used, for example, for biosensing purposes. Here you see one of my study, which is in preparation. So by screen printing in high throughput also, printing of these layers, that's possible. The printing die can print really in the thin ranges of inks in a really short time. And there are screen printed P.PSS mix sensors on a single foil again. Those were used for DNA sensing purposes. But the sensing efficiency was not that high. But still, up to some point, I was able to sense some strength. Okay, next slide, please. Another interesting feature of these conductive polymers are that in the wound healing process, when you use them, in very short times, the wounds getting closed. Imagine you have a surgery and inside your body, when they sew the surgeon sews the organs, you need something really fast. And this electrical discharge, this is promoting the wound healing inside the tissues, which is incredible. Another way where they use nowadays the conductive polymers are that they produce devices for drug release purposes, transdermal devices we see wearable, stick onto the skin. The next, please. Thank you. So that's all that I wanted to share as a closure talk maybe of today. It was a great pleasure to receive an opportunity to talk today. Acknowledgement goes to European Union Commission, of course, the companies listed. I'm available in LinkedIn, and if you want to contact me, the email address provided. Thank you very much for your attention. Any questions will be welcomed.
Please go. Şeyleri dolandırdınız böyle başımızı da döndürdünüz. Ben de yani kısmen anlatıyorum vesaire ama hakikaten son gelişmeleri görmek çok güzel bir şey. Bu baştaki rol aslında biraz da bizim team'in rol casting'e benziyor. Yani bir net shape casting var ya son nihai boyut veren. O metotta polimere kazandırmış olduğunuz özellikler yani roldan mı kaynaklanıyor? Yani geleneksel başka yöntemlerle o ince şeyi verirseniz aynı özellikleri kazanmıyor. Yani rol ne yapıyor orada? Bir soru aklıma geldi ama. Orada sıvıyla mı başlıyorsunuz?
Evet hocam. Şimdi çok güzel soru. Ben şimdi limitli sürede gidince heyecanlanıyorum.
Yok zaten akşam oldu. Aynı savaşladım.
Sohbet başlayabiliriz hocam.
Normalde bu ticari olan çipler Avrupa'da injection molding ile üretiliyor. PS'den falan yapılıyor. Sert bir üst tabaka var. Altta da yine foil tabakası var. Fakat bu maliyetli oluyor diye bize talep öyle gelmişti. Yani firma biraz arz talep üstüne proje geliştirdiği için bunu nasıl yapabiliriz diye başlamışlar. Tam o başlangıç aşamasında da ben o sene oraya katılmıştım. Bir pilot kuruldu Avrupa Birliği'nden fon alınarak. Buradaki amaç tek bir folyo üstüne bütün yapılandırmayı, şekil vermeyi yapıyorsunuz. Yani injection molding biliyorsunuz hocam çok daha zahmetli. Ciddi şekilde tek folyo üstünde baskı üretim maliyetini de ciddi şekilde düşürüyor. Bu tabii daha ince olduğu için diğer bir cihazın, bu medikal cihazın içine girecek. Alttan sinyal okuyacak cihaz, bu çıkan floresan, daha doğrusu kemiluminesans ışığı. Bunu okuyabilir mi dediler. Şeffaf olduğu için, bu avantaj olduğu için cihaz okuduğunu ilk fark ettiler. Bir baskı yapıldı. Tabii bunu bir dakikada binlerce çip üretiminden bahsediyoruz. Bu şekilde bir continuous hat üzerinde yaptığımız zaman hem maliyet düşüyor hem zamandan yani daha kısa sürede daha fazla çip supply edebiliyor firma. Çok büyük avantajları oluyor.
Yarı kristalin vesaire özellikleriyle bir ilişkisi var.
Yok hocam, yok. Ama bu folyonun üstüne ilk başta pilot hat rezin kaplıyor. Termoplastik bunlar. Termoplastikler bir rezin kaplıyor. O rezin baskı yapılırken baskı aşamasında arkadan bir ışık vuruyor. Pilot hattın o ünitesi o şekilde çalışıyor. Aynı anda da unshrifted duruma geçiyor. Tabii çok temiz baskılar yapılabiliyor. Mikron mertebenin de altına yani nanoya yakın kanallar da basılabiliyor. Çözünürlük çok yüksek bu teknolojide. Ben teşekkür ederim.
Any other questions?
Nano kanallar nasıl basıyor?
Injection mı? Pardon hocam, bir daha söyler misiniz?
Yani mikro kanal tamam da nano kanal olunca işin boyutu değişiyor. Yani o çözünürlüğü nasıl yakalıyor?
Basabiliyorsunuz ama çok dar nano kanallar basamıyorsunuz. Orada bir limit var, çözünürlük limiti var. Yine kalıptan aktardık. O tarz bir tane makale var. Geonem Research'ten çıkan.
Yani kanal için litografi mi yapıyorsunuz yoksa?
Şimdi o kanal sıvı kür olmamış bezin üstüne bir şablondan geçer. O sırada da UV ışıkla küvredilir. Aynı anda oluyor bu proseste.
Onun bir erkeği veya dişisi var sonuçta.
Evet.
Onu nasıl hazırlıyorsun?
O maskeden litografiyle master'dan sistemde geçer. Sistemde manyetik bir sistem o baskı ünitesine rolun üstüne dolandırıyoruz onu.
Print ediyorsunuz.
Printing yapıyoruz, evet. Aynen o şekilde.
Thank you very much, Dr. Gülsoy, for your presentation. So this was the last presentation. I'm closing the session for today. I thank everyone who participated on behalf of the organization team and the chair. Have a good evening.